All right, here we're going to work on this study guide, and we're just going to start off. We have some easier questions towards the beginning. The study guide is actually in order of essentially how a textbook would order topics. So, it should kind of progress and all build on each other. Here it says combine like terms. What is the simpler form of each expression? So it says each expression because there might be more than one. See the bold directions? Bold directions, more often than not, apply to all the examples under it until you have new bold directions. Everyone got that? Okay, so if I'm going to combine like terms, Carol, what should I do to begin this problem?
Distribute.
Nice. If I distribute, what do I get, Sahai? Good. 3y minus 21, and then minus y next to it, right? All right, so right now, here I am. Remember, you're allowed to have a calculator out, and you're allowed to use one, so if you mess up your negative and positive stuff, check it in a calculator. I have calculators magneted all over the boards over there, so if you want to grab one for later problems, help yourself, okay? Here, what does this turn into? I need to simplify and combine like terms. So if I want to combine a little bit more, Josh, what else can I do on this example? Okay, so 3y and the minus y, so that became, what was it? Good, 2y, and the minus 21 just stays there. Since there's no equal sign, that's it, you're done. And that's your answer, okay? So if it were multiple choice, make sure you don't get lazy. I would say that's where a big place where people make mistakes is they do some parts in their head and then they're like, oh, it must be this one, and they don't even finish the problem, so then they mess up, okay? Next example, underneath it. So it looks like a word problem, but we actually don't even have to do too much with this word problem here. So on this problem, we are asked to do a rectangle is 5 times as long as it is wide. Now, again, we're not solving anything. It's just going to ask us to set up equations. I'm going to go on the side. I'm just going to sketch a little rectangle for myself. There's my rectangle. What letters should I do to represent the sides of my rectangle? What letters do we usually use? Sure, W and L. Do you want this one to be W or L? I heard L, okay. L, then that is also L if it's a rectangle. Makes sense? And then these will be W and W. No, it doesn't really matter, right? Base height, LW, whatever you want to call it, XY, surprise me, right? There's my rectangle. All of these are right angles. Maybe in geometry you did the little tick marks to prove like, oh, these are congruent. We don't have to go too crazy. A rectangle is 5 times as long as it is wide. So pretend I had the lengths of the sides. If something is 5 times as long as something else, what do you do to figure out the other length? Like if I told you, oh, or other width or whatever, if I told you, oh, something equals 10, but something is 5 times longer than it, how do you get the other side? If I told you like, oh, this shape over here, I have one side is 10, and I said this side, oh, I cut off, this is 10, but this side's 5 times longer. How do I get my new length? Exactly, 10 times 5, and what would it be? 50, okay, good. So who's longer according to this sentence? 5 times as long as it is wide. Is the length bigger or is the width bigger? Which one? I heard it? Someone said it. I can't hear though. Which one's longer, length or width in this case? So it's 5 times as long as it is wide. So let's say the width is 2. If the width is 2, it's 5 times as long as it is wide. Then how long is it? So who's bigger? Length. So that's going to be the trickiest part. Length has to be bigger than width in this case. So you always read that very, very carefully, okay? So that's going to be important. So what equation can I write down for myself? Who do I multiply by 5? Do I multiply width by 5 or length times 5? Say it again. The width. Yes. So the length is 5 times the width. Does everyone see how that makes sense there? That's honestly the hardest part of like the next 10 examples. This spot right here, because this phrase is a little tricky. 5 times as long as it is wide. So the wide, that part, gets multiplied by the 5. Next, the perimeter is 50. How do you find perimeter of a rectangle? Does anybody remember perimeter, Armand? Good, so if I add up all the sides, what can I write on the paper for that? Sure, L plus W plus L plus W. So perimeter is 50. Armand said L plus W plus L plus W. Maybe you know it as another equation. Does anyone know another equation for perimeter? Like instead of writing it that way, maybe jumping to something else? 2 times L Right, they're really the exact same equation. So either way that you start, you'll be good. So 2L plus 2W equals, what's the perimeter in this case again? 50. Okay, so Armand's equation's good, but we would combine like terms anyway. So here I have that equation, right? So I have that equation which went with my perimeter sentence, and I have this equation which went with my 5 times as long as it is wide sentence. Now, which system of equations? What's a system of equations look like? Yeah, the stuff we did substitution elimination on where we had 2 equations, right? Which system of equations can be used to solve for the length and the width of the rectangle? We're done. That's it. They're just asking you what equations would model this problem. They don't even need you to solve it. That's it. Okay? You're finished. What is, just as a side note, make sure we remember stuff. Do you guys remember how to find area of a rectangle? Since we have the perimeter formula here, what about area? Here's the rectangle. The area is the whole inside, right? Gabby, do you remember the area formula? So if like you had 10 by 50 over here, and I asked you what's the area inside, what would you do with the 10 and the 50? Exactly, so you do know the formula. Ready? It's L times W. So you know it, all right? So that's just the area formula on the side, just in case we need it. And then that formula, again in green, is the formula for the perimeter. Good, done. Can you guys try to set the next one up by yourself? It's identical, okay? Take a second and try to set that up by yourself, and I'm just going to hit pause, okay? All right, so I got these equations right here. Did everyone get, oh, of course I wrote the wrong thing, so I was looking up. See what I did? This should say L equals 3W, thank you, and 2L plus 2W, because it still said perimeter, it didn't say area, is 90. The word is, a lot of the time, not all the time, but a lot of the time means equals. So perimeter equals 90, all done. All right, next is what we have is absolute value equations. Now, recently, we also did absolute value something else. What else did we do? Absolute value, not equations, but good, inequalities. Inequalities are different because instead of an equal sign, what do they have? Yeah, less thans and greater thans, exactly. So this is actually going to be easier. You know why it's easier? Because you don't have to flip, no flipping of the sign, right? No number line. Remember we would draw it on a number line. And no, remember this thing? No interval notation. Okay? So for an absolute value equation, we don't need that, we don't need that, we don't need that. But the only thing you really have to remember are the 2 main steps. Step 1, what are you supposed to do first when you have absolute value? What was the first step? Soroya? Yeah, she's right. You're going to add 3 and then you're going to do something else? Yeah. Why are we trying to do that? You're right. Yeah, we're trying to get this alone. So that's called, so step 1, isolate. You guys know what isolate means, right? Isolate the absolute value part. So that's the one main thing we have to remember. Absolute value part. What was the other thing we have to remember for step 2? After you get it alone, so Roy is right. After you get it alone, we have to do something else. Yeah, there's going to be, so step 1, so look how we can remember. See the 1 kind of looks like an I? Step 1, isolate, right? You could even make, you know when people are clever and they do this? And they put like a number in their word? You know, like when people put like, if you're graduating, what year are you graduating in? They put it in like the word seniors. They try to put numbers in it so it shows the year. You ever see that? You know what I'm talking about? Yeah, like if somebody is like, I don't know, what year are you guys graduating? Yeah, you guys do it, right? So this year is graduating in 20. So how do they write seniors? 2. It's not a good one? No. Yeah, people are, they're clever though, right? Like if you were graduating in 2010, they would do, you know, like that's a 10. Just whatever. You get what I'm saying? Okay. Anywho, 2 is going to be 2 equations, but we'll get to that in a second. So what did Soroya tell me to do first, Nicole? She said to do what? We want to get rid of the minus 3, add 3 to both sides, plus 3, plus 3. So Nicole, next step, that 3 is still there with the absolute value. What's on the other side? I did 12 plus 3, so good, 15. Next step, I know it's a little squished, so I'm going to move over a little bit. So I'm going to rewrite mine, 3, and then 3x plus 5 equals 15. So say, 1. This 3 out front, how is this 3 attached to the absolute value? What operation's really secretly between them? Perfect. It's attached by multiplication. Even if it were negative, guys, it's still multiplication. So like one just said, so you have to get rid of it with division. Divide by 3, divide by 3. Those 3's are gone. So next step, Emerson, I have the absolute value of, I'm just going to move it more to the side. I'm going to color coordinate these examples since it's a little squashed. I apologize. If you didn't copy all that, you'll have more room. So that was number 1 and number 2. So I'll get absolute value of 3x plus 5. Just watch that your absolute value bars don't look like 1s, okay? Equals 5, we just said, right? Yeah. All right, Emerson, what do I do next? Step 2 is 2 equations. Do you know what my 2 equations would be for this? Say again? Yes. The inside you don't touch. Pretend like it's in a force field. It's being protected. So 1 is going to be the same, positive. So 3x plus 5 equals 5. And now Emerson said 1's going to be negative. He's correct. 3x plus 5 equals negative 5. And all you do is just solve, all you do is just solve both and we're good to go. So, Jeremiah Ricks, if I was trying to get x alone in this equation, okay, what would I do first? Say again? Not divide yet. You want to get rid of this. So how do I get rid of a plus 5? Yeah, we're going to do minus 5 on both sides. Now, the other day, some of us were solving systems and there was a 0 in the work. And you guys were like, I think I messed up. I got 0. But 0 is a number, so don't panic, okay? Here you'll get 3x equals 0. Really, what do you do to both sides next? Anybody? Yeah, we're going to divide by 3. 0 divided by 3 is 0. So x equals 0. That's one answer. Here, if I subtract 5 again, if I subtract 5 from both sides now, Jahari, what do I get? 3x equals how much? Good. Last step, just finishing this for the video here. Divide by 3. Nice. So that's the other answer. X is, leave it as a fraction, or you could change it into, what kind of number can you change this fraction into, other than a decimal? It starts with an M. Mixed number, okay? So those are my 2 steps, and we'll continue tomorrow. We have a short period today, all right? Good job. Once you get an absolute value alone, when you're solving an absolute value equation, you set up your 2 equations. To refresh, the 2 equations are, you keep the inside the same for both, 3x plus 5, and we set it equal to positive 5 and negative 5. Just a little side question. What would happen if it said the absolute value equals negative 5? Can the absolute value of things ever equal a negative number? No, you would write no solution. Okay? So that's how you set up your 2 equations. So then we set it equal to the positive and negative, and we solve both. So now we're going to do this one. I don't have to write as much down because I have some notes. So step 1. Step 1. Sam, what should I do first in solving number 5? What should I do first?
Repeat the question.
Good, Sam. Yes, you would add 4 to both sides since we want to isolate the absolute value. That is what we would do first. Good job. Add 4 to both sides. That leaves you with 4 times the absolute value of the 4x plus 5 equals, what number do we get on the other side? Jeremiah Rick, 16 plus 4? Nice. Next step, what do I do? Divide by 4. Good. If I divide by 4 on both sides, dividing by 4, next step, I'll get absolute value of 4x plus 5 equals 5. Nice. 4x plus 5 can equal either negative 5 or 4x plus 5 equals, what was it?
Positive 5.
Nice. And then we just solve from there. In both cases, what do I do in the next step? I'm going to do what?
Subtract 5.
Minus 5. All right, minus 5 on both sides. That gives me, and I know I'm squashed, I should have left you more room, I apologize. 4x equals, what's negative 5 minus 5?
Negative 10.
Negative 10. I'm just going to circle my work, okay? I'm going to go like this so it's sideways. Divide by 4, and what's 10 over 4 reduced to? So it's negative 10, though. Good, negative 5 over 2. So down here, x is negative 5 over 2. Okay, I'm really sorry it's squashed, so I'm going to draw an arrow. The one answer was x equals negative 5 over 2. Here,
You subtract 5.
subtract 5. In this case, we get 4x equals what then?
0, and then x equals 0.
Right, because if you divide, you still get x equals 0. So that guy I'm going to go over here, and also x equals 0. Okay? So that was the other one that I'm just going to circle a little bit. You will have scrap paper on the exam, okay? So you will be able to hopefully just write it all out nicely, and you'll have a little bit more space. But I knew the review packet had extra questions, and I wanted you guys to all fit everything there. So yeah, this example looks a little scary at first because there's fractions in it. But guys, I showed you a way to help us get rid of fractions. By looking at number 6, if you wanted to get rid of fractions, what could you do? Take a second, don't shout out, let everyone think. What would you do to get rid of fractions in number 6? I have denominator of 5, and really this is a denominator of 1. So everyone think about it. Everyone think about it. What could I do to make my life easier? All right, Armand, what could I do? Not the reciprocal. Someone have a different idea of what to multiply by? Go ahead, Jay. Yes. Multiply by the least common denominator. That's one option. If I multiply by 5, ready? What happens? Yeah, 4 over 5. If I distribute 5, the 5's cancel. So what's left for my first step? 4x plus. All right, Nicole, what would I get here when I multiply everything by 5? 2, yeah, what did you say? 2y, you're correct. So that would be 2y. And what would I get, Moreau, on the right side of the equal sign? 30, good. Now, let's go back even and look at the directions. So we got rid of our fractions before we even read directions. Makes our life a little easier, less scary. Write the equation in slope-intercept form. Does anybody remember, raise your hand if you remember, what is, on my notes here, I'm going to put on the side. And I still have that bucket somewhere in the room with the markers and highlighters, so if you want to use it, you can. Slope-intercept form. I need to know what slope-intercept form is. What is slope-intercept form of a line? Josh? Nice. Y equals mx plus b. Now, if that's slope-intercept form, well, that means I got some work to do because mine doesn't look like y equals mx plus b right now. Sorry, I'm just trying to fix the focus. Mine doesn't really look like that right now. So how can I? Why is it so blurry? Okay. What can I do? Right now it looks like this. I need it to look like that guy right there. Jahari, what's something I can do to this equation to get it a little bit better? Yeah, subtract the 4x. Does everybody see I need the 4x to go to the other side? So we're going to do minus 4x and minus 4x. But how should I write my next line? What could I write for my next line of the equation? Cairo, go ahead. Nice. We put the x1 first, so it looks more like mx plus b. Now we only have one more step. Aaliyah, what do I need to do to this to get it to look like this?
Divide by 2.
Beautiful. And we divide everything by 2. Now when I divide everything by 2, so Aaliyah, finish it up. We end up with y equals? Nice. All right. Now write the equation in slope-intercept form. Now the follow-up. What are the slope and y-intercept? What letter do we use for slope? M, good. Slope, which is M. Soroya, what's the slope in this equation? Good, it's -2. So I'm just going to scoot that over. -2. And what's the y-intercept in this equation, Ovan? Good, it's 15. So you could either write it like, sometimes people write just 15 down, or we could write it as an ordered pair. So maybe you even write 0, comma 15. Okay? So there's the slope and the y-intercept. This would potentially be, if it were open-ended, well, I think it's pretty easy. If it were multiple choice, my advice, big star, multiple choice advice, do not say that the slope is 4/5. That's my big advice. Why are people going to pick an answer saying the slope is 4/5 for a question like this? Why would they pick an answer that said, oh, the slope is 4/5? Because it looks like it's m because it's in front of x. But it's not m unless your equation looks like that, okay? Cairo, question?
Are there any questions like that to ask you, what the slope is?
Yeah, so this is a review packet exactly like it. So once you get it to this form, it's going to ask you for those things. So if it were open-ended, you just have to finish. And you could even just go like this, though. If you circle that, if it's open-ended, go like that and just write slope. You know, that's good. As long as you show me, you know where it is, you know? And if you circle that and you go y-intercept, that's fine, right? You know, like I don't care if you just circle it and label it. That's okay. And if it's multiple choice, just read all the choices and find it. Okay? I'm sorry, say it again. Oh, sorry, I'm a little too zoomed in now. That should be a little better, right? Okay, so that's that one. Do you guys want to try 7 by yourself for a second? Let's try it. Ready? I'm going to hit pause. All right, everyone flip your page. Top of the next. Okay. All right, so we're going to go ahead. We have 3 methods to choose from: graphing, substitution, or elimination to solve this system. Vaughn is going to tell us what we need to do to solve by graphing, since we have a graph right here ready for us. Go ahead. Okay, good. We're going to start at 3 on the y-axis. Good, and then? Down 3. You're right, down 3. And right 2, good. Negative 3 was down 3, right 2. But if I wanted to continue the line this way, I can go up 3 and left 2 that way. Good. Pretty nice line. If I have a little bit more room, up 3 over 2, I could fit 1 more point over there by the 9, up there at negative 4 at 2. All right, first line is more or less done. Maybe you take a ruler, a straight edge, and you try to draw it nicely. So you don't want to be sloppy when you solve by graphing. Also, all linear equations should have, at the end, arrows. How about the other line, Soroya? What can I do for the other line? On the y-axis, we put 8, good. Up 1 and over 1, nice, right. She even said right instead of over, so she's specific. Down and left 1, down and left 1, winner, winner, chicken dinner, down, left, down, left. Do you guys see I hit the answer? So you have to be really careful and neat. What is the answer? The answer is not just a picture. We're solving something. What is the answer, Cairo? Good, negative 2, 6. To find the answer for these, we essentially find them by solving by looking at the ordered pair. The solution is where do they cross? What would happen if you had 2 lines that had the same slope? What would happen if we had 2 lines with the same slope? Would they intersect if you have 2 lines with the same slope? Well, if they have different y-intercepts, that would be no solution, right? What if they have the same slope and the same y-intercept? What if they have the same slope and the same y-intercept? So I have this line, then I come back and I have this line again on top of itself.
Infinite.
Right, that would be infinite because it's overlapping itself. But usually when they have you practice in algebra, they give you 2 intersecting lines, but that doesn't always happen, okay? Next one. Can we do this one by ourselves a little bit?
Yeah.
All right, let's go for it. I'll hit pause. So Armand, what did you get for number 9 for your answer?
He didn't do it.
Sam, did you get something for it?
Nope.
Emerson, did you get number 9?
I got negative 1, comma 1.
All right, let's see if Emerson's correct. We have an answer there. Did someone get something different? What'd you get, Gabby?
I got no
You got no solution?
I got no solution.
Well, all right, let's look at it. I'm going to say no solution is not correct. The only time that you would get no solution is if you had parallel lines. Do they have the same slope?
Take your AirPod out.
No, but they're not the same slope. All right, so let's look. Ready? Where does this graph?
When I graphed it, 3 on the y-axis.
So let's see.
It's so disrespectful.
Where did we start this line?
3 on the y-axis.
Good. And what's my slope?
Up 2 over 1.
Up 2 over 1, up 2 to the right 1, up 2 to the right 1, down 2 to the left 1, down 2 to the left 1. Okay, there's the line. I'm going to make it pretty long and go like this. All right, this one, J, where should I start with that one?
Negative 1 on the y-axis.
Negative 1 on the y-axis, and then?
Down 1 over to the left 1.
No. Okay, that's where things get a little fuzzy, but either way, they would cross.
Wait.
That negative in front,
Right.
negative 1 is really a negative 1 over positive 1.
Okay,
That's what that is, because if you do 2 negatives, what does it become?
positive.
Right. So here, I'm going to go then where?
To the right 1.
Down and to the right, or I can go up and to the left, up and to the left. So my lines, do they intersect at a nice point? No. So why is graphing sometimes not a good idea, guys? Because sometimes they graph and they intersect somewhere at like decimals. So if that happens, and it's multiple choice, maybe you could figure out what answer looks closest to where you found them crossing. If not, or if you think your lines don't cross, then maybe you should try another method. What other method, other than graphing, would be really helpful in this example? Vaughn, which one would be pretty good? Nice, yeah, substitution. So if I do substitution for this, what do I know y equals? Well, it equals both of these things. So if y equals that and y equals that, it equals both of those things. Jahari, what can I do? If I know y is equal to 2x plus 3 and y equals negative x minus 1, how can I solve this using substitution, really? What step would I do? You know what y equals. Yeah, negative x minus 1 in front of like equals 2x plus 3. So some people call it set them equal to each other. That usually works when they're both y equals. Do you guys see that? Makes it easy. Okay, let's solve this. How do I solve for x? What should I do first? Anyone?
Add 1.
Add x to both sides. You want to avoid negatives, right? So we add the x. Now what? That's gone. You're left with -1 equals 3x plus 3. Good. Keep going. Got to get x all the way alone. What do I do now? -3 minus 3. Remember, you'll have a calculator, so if you need to use it, then use it. 3x equals? Nice. -4. And then, oops, giving you a hint. Good. Divide by 3. Now, I love improper fraction. Just leave it alone. So x equals -4 over 3. That's a fraction. It's a decimal. If you got -1.33333, then you're not wrong. Okay, that's what that is as a decimal. Now, that's just x. Are we done yet? Sorry, full flush. Is that finished? What do we do now? Say it again. I heard. We need y. So if I need y and I have x, I should take this and, yeah, which equation's easier, the top or the bottom? Yeah, I think the bottom. So I'm going to do negative, I'm plugging in -4/3 minus 1. What's a negative times a negative? Good, so that's 4/3. Now I want to do 4/3 minus 1. If I'm doing 4/3 minus 1, I should change my 1 into what?
1/1.
Sure, and then? Yeah, and then it turns into 3/3 because we found a common denominator. And what's 4? This is what y equals. What's 4/3 minus 3/3? Nice, 1/3. That's the y. So my answer, it shouldn't be that. Let's erase it. How can I write my answer as an ordered pair? Jeremiah M? So I got my x, I got y. I know it's all over the paper here. X and y are found. Well, let's fix it up a little. Nicole, how do I write my answer? So Jeremiah M, make sure you listen. Go ahead. Because it's -1, right? But I can't do like a fraction, take away 1. I need a common denominator. So I just took the 1, and it's really 1/1. We multiplied on top and bottom by 3 to make it 3/3. You know what I said? Okay? So here's the y answer. Here's my x answer. Sorry, my work is a little crazy over here. So Jeremiah M, do you want to try to fix it yourself what the answer is? I think you said it a little backwards.
1/3.
But x comma y, let's try again. You're saying the same thing. My ordered pair, x comma y.
Oh, yeah.
So what is that, Jer? -4/3? No, that's x. I highlighted it for you. Do you see everything? Now the 1/3. You were saying the ordered pair backwards. That's why I was saying no. Okay? You hear what I said? That you were saying to me first, and then you said that number, but it's x comma y, not y comma x, when you do an ordered pair. Okay? Does that make sense? Because it's asking where they cross. So it's -4/3, positive 1/3. Okay? Here, what method is this one set up for? Pretty nice, that would work. It really says you could use any method, but which one looks pretty good? Elimination. JR, do you see that this is set up for elimination? A little bit? Because the 2's are the same. So JR, if I want to eliminate it, I want the x term to go away, and they both have a 2 in front of the x. Should I add these equations together, or should I subtract the bottom one from the top? Yeah, good. We're going to subtract the bottom one from the top. You guys will see that that will make the x term go away if I subtract it. Some of you might call it multiply by a negative and then still add. That's the same thing, okay? Moral question? Yeah. All right. Other questions, Sam? Yes. So that's still there. If you need that a little covered up. Now, if I subtract it, 2x minus 2x is gone. Negative y minus negative 4y. What's minus negative mean? Hold on. Plus, so what do we get? Careful. Negative y plus 4. Say it again. Oh. 3y. I thought you said negative 3y, but you're right. Yeah, 3y equals, Armand, what do I get for the last column here? 6 minus, yeah, you get 6. 6 minus 0. Avery, if I have 3y equals 6, what's my next step? To divide by 3, and y equals 2. Plug it back in. 2x minus 2 equals 6. Add 2. I'll do this over when I see you next. Do not lose them if you want to put the packets there. 2x equals 8. Divide by 2. X equals 4. Thank you. Answer is 4 comma 2. Okay, so now we're going to solve this exact same example, number 10, with substitution instead, okay? In order to do substitution, you need to get one letter alone. So I'm going to use my first equation because I like that one because y has a negative 1 in front. It's better than it having like a 2, a 3, or some other number. So I'm going to rewrite 2x minus y is 6. How do I get y alone? What should I do first, JR? What should I do first to get y by itself?
Add the 2 back, multiply the 2 back.
Good, subtract 2x from both sides. So minus 2x and minus 2x, perfect. That was step 1. What do I get to write for my line now, August?
I was just going to ask if you could also add y to both sides.
You could have added y and then brought the 6 over, but we're going to leave y on the left, so either way would be fine. So what would I get for the next line after JR's step?
Oh, negative y equals 6 minus 2x.
Sure, or I would write negative 2x plus 6 just to practice like mx plus b form, but they're both correct. You could write 6 minus 2x. Now, is y alone yet in this example, Miro? No, we still have to do something else. Don't lose this negative sign, okay? A lot of times that just falls off, people forget about it. What do I still have to do, Miro? Good, if I divide by negative 1 though, watch that you divide everything. Again, this is where people make their mistakes. So if I divide by negative 1, Emerson, what do I get for the next line? Good, minus 6. I feel like I see a lot of plus 6 by mistake. Okay, so that was equation 1. All right, I'm just going to call it 1 like that right there. That was equation 1. Now, if I want to solve by substitution, I'm going to bring equation 2 over here. Here's equation 2. 2x minus 4y equals 0. And that's equation 2, and equation 2 right here. What do I do with that? Equation 2 of 1. I got equation 1 down looking like this. I rewrote equation 2 over here. What do I need to do? I don't need to, this one? We don't need to do that for substitution. We're kind of already ready. Like you don't really need to do that. I know what you're thinking, but we don't have to do that extra step. I'm just trying to use substitution. I know that y is equivalent to this. Yeah, I'm going to fill it in and sub it in for that y over there. Everyone see? Yes? Okay, so then I'm subbing it in. 2x minus 4, 2x minus 6, that went in, is 0. What do I do next, Armand? Good, we're going to distribute. Can you tell me what I should write down if I distribute? Well, let's start with the beginning. 2x. No, you told me to distribute, so I slow down and distribute. You're not distributing. No. Thank you, minus 8x. And then, Armand, redeem yourself. Thank you, plus 24 is 0. Next step, Jay.
Combine 2x and negative 8x.
It gives us,
Negative 6x.
good, negative 6x.
Plus 24, add 24 over, subtract it.
So subtract 24 over, good. Minus 24, so I have negative 6x equals negative 24. One more step, really?
Divide by negative 6.
Good, so we get x equals, sorry, I'm a little squashed.
Positive 4.
Good, there's x equals 4, and again, we're not done. Once you get x equals 4, we can maybe go back over here. So I'm just going to draw a crazy root, but I'm going to get over here. I'm going to fill it in. Y equals, so you're filling it in. Does it matter which equation we plug it into? No. So over here, I'm filling in. I got the answer for x. X is 4. I'm going to fill it in right here. 2 times 4 minus 6. So this is where the 4 goes. And then what does it work out to give me? What do I get for the next step, Sahai?
Y equals 8 minus 6.
Which is 2. So there's my y value. Y equals 2. Final answer, ordered pair, 4, 2, and we're done. So really, graphing would have been fine for this one as well, but the only issue is we did graphing in the one above it. So I just wanted to show you 2 different ways. Good? Great. Again, I will upload this once we're all finished, and you'll have one, or at least halfway, and I'll do the other half of the packet in a separate one. Here. Okay, here I even tell you what the one word means, because sometimes we don't know the word, recognize it right away. But it says, what is the average rate of change? And what did I say average rate of change really means, Nicole? I wrote it on the paper for us. Come on, we're on number 11. You're just literally reading the word next to it, Nicole, okay? What is the average rate of change, and what did I tell you average rate of change means? Thank you. Don't say you don't know. You know. Okay, it's the slope. Find the slope. What is the slope for the interval between point B and point C? Now, you got to be careful. Here you have 2 points on the graph, but you have a third point. So there's 3 points labeled, so pay attention to which one we're dealing with, okay? So Sam, we're trying to find the slope between point B and point C. What is the slope formula? How do I find slope? Slope formula. We've gone over it. It's in your notes. You should have a notebook. Can someone help Sam with the slope formula? Armand? It is rise over run, but that's not a formula. Those are words. So I'm going to write that down, though. M, which we use for slope. Which we use for slope. He's not wrong. It is rise over run. But Josh, what's something better we could say?
M equals y
y2 minus y1 over x2 minus x1.
All right, guys, you need to know this, okay? Without a doubt, this should not be even a hesitation. You've been doing slope for many years, okay? Without hesitation, you need to know all formulas that are being used on this, okay? So there's my slope formula, and I'm trying to go from point B to point C. Now, if you look at the picture on your graph paper, Avery, what's the ordered pair for point B? 2 comma, not 2, 2. Yeah, 2 comma 0, good. And Avery, what about point C? Flip it. Good. So these are places that you guys make mistakes sometimes. This is over 2 and up 0. So that's this point right over there. But you always go left and right first. This is over 3 and up 5. So that's B and C right over there. Now I wrote them down so we could practice the slope formula, and then I'll talk about another way to do this. Underneath them, I'm not trying to be a hero. I'm going to label x1, y1, x2, y2, and then I'm just going to fill them in to the formula that Josh gave me. So m, which is the average rate of change, its slope, equals y2, 5, minus y1, 0, over x2, 3, minus x1, 2, equals, well, 5 minus 0 is, 3 minus 2 is, 5 over 1, well, that's just 5. Done. What's another cheap, easy way we could have done this problem? Can you tell me, Sam? Go ahead. What's a cheap, easy way? Come here, Sam. What's a cheap, easy way to do this problem without even writing a formula down on your paper? What can we do? Emerson? Yeah, you're right. You guys hear? He said we're going to count. Basically, if you have a nice graph in front of you, just use the boxes, okay? Time is money, right? So,
Y equals 5x plus 2.
well, we don't need the equate 5x plus 2. No, that's not the y-intercept. That's an x-intercept. But they're not even asking us for the line. That's this one. Our line would have this intercept, not this one.
What's the answer? Like, what's
The answer is just asking for slope. That's the answer. You're done. Okay? Now, the way Sam said is you're just going to count. So I went up 1, 2, 3, 4, 5, and then I went over 1. Why do you think this could be confusing with the extra dot? What might people do? What is something people might do by mistake and lose points or get it wrong? If I give you 3 dots on the paper, they might find the slope between or the wrong 2. You can't really find the slope between 3, right? They might use the wrong 2 points. So just make sure that you're using the correct ordered pairs, okay? And that's the end of it. That's it. Everyone see? That is literally all you have to do is find the slope. The end. Okay, next. What is this equation going to look like? It says graph. What is the graph of the equation? It's y equals x squared minus 2x plus 1. What will the graph look like? What is the name of the graph of this, Jahari? What's the name of the graph of this kind of equation? Okay, don't put your head down. Morel, what's the name of the graph of this? Yes. While the equation is called a quadratic, the graph, so the equation is called quadratic. Oh, look, I wrote equation, sorry. It's called quadratic. The graph is called a parabola. Now, we just most recently did have an assignment, a quizzes assignment for the review that was reviewing how to graph a quadratic. What are some important, or a parabola, what are some important features you're going to want to include in your graph? Or do you remember what the graph of a parabola looks like? What shape does it have? Kyra, what do you remember? Yeah, it looks like a U. What is something else that is important about a parabola? Maybe you could name certain points for me?
Keeps going outwards.
Yeah, okay. But what's an important point to get graphed? Good. Vertex. Jeremiah M., do you remember the equation for finding the vertex of a parabola?
Negative b over 2a.
Negative b over 2a, that's the x value, the middle of the graph. And then how do you get the y value that goes with it? Who remembers what you need to do? A 1? Well, that's something. I'm going to write that over here. That's your y-intercept. They're both y values, but 0c is always your y. Squeeze that over here. Your y-intercept. So the y-intercept and the y value of the vertex are different. So I'm going to redraw a little sketch over here to kind of point those out. Sometimes they are the same, but usually they're not. So if I go over here, if I make this my vertex of my parabola and I draw this, that is my y-intercept. That's 0, c, because this is my y-axis. Can everyone see where the y-axis is? And your y-intercept is where we cross it. Here's the arrows because Armand says that it goes on forever. But now this is the vertex. The vertex is your highest or lowest point. Avery, sit up. This is your highest or lowest point. The vertex is what that is. So the x value for it is that negative b over 2a. But how do I find the y value that goes with it, Armand? How do I find the y value of the vertex if x is negative b over 2a? That's it, guys. Everyone heard? Plug it in. Just plug it into the equation, plug x in, and you'll get the y value. That is it. Then we just found the one that was symmetrical to it, and we called it a day. Okay, so what's a, what's b, and what's c in the example? Y equals, this is what it looks like, ax squared plus bx plus c. So a is really what number? Anyone, everyone? 1. B is? -2. C? 1. Good. So which point can we plot first? What's one point I can plot right now? The y-intercept? Sure. That's going to go on my y-axis. Does the y-axis go left and right or up and down? Up and down. There's my y-intercept. Plot. Done. Okay? Vertex. Vertex. I need to find my x and my y of my vertex. And I got my formula from Jeremiah of negative b over 2a for x. So, x equals, negative means opposite. What do I put for negative b, Sahai? Well, it's already negative, and the formula says, good, we're changing it to positive 2 over 2a. And what's a? Anyone? 1. It's the number in front of x squared. If you look over here where I rewrote the formula with just letters, a is the thing in front of x squared, not x squared, okay? Now, Gabby, 2 over 2 times 1, what do I get for my x value? 2 over 2 times 1 is 2 over 2, but what do I get? 1, all right? 1 is the x value of my vertex. That's where you can draw this dotted line, all right? So negative b over 2a, I'm going to highlight that in pink, color coordinating here. While I got x equals 1 for it, that is this dotted line. Does anybody remember the name of the dotted line? Nafia, do you remember what this dotted line is called?
Is it axis of symmetry?
It is. Thank you. Beautiful. All right. Axis of symmetry. Axis of symmetry. So it's really showing you the line that you could fold your graph over. Now, I still need the y value of my vertex. So I still need the y value. So I'm going to take the 1, and Armand told us we're going to plug it in, okay? We're going to plug it in. So JR, if I plug 1 into my formula, here's the formula, my equation rather, y equals x squared minus 2x plus 1. I'm going to fill in 1, okay? Oh, Laura, let me fix the focus. I'm filling in 1 into the equation. I'm down here on the bottom of the page. So I have 1 squared minus 2 times 1 plus 1. JR, what do I get for my y value when I'm done? Well, I get positive 1. That's 1 squared. Take away 2. What's 1 minus 2? Okay, and what's negative 1 plus 1? Good, we're going to get 0. 0 is the number 2. Don't be afraid of it. So my vertex is at 1, comma 0. That was the 1. 0 is the y value. So together, they make 1, comma 0 for the vertex, okay? That's the vertex. So I'm going to go over here with a different color. My vertex is 1, comma 0. There's the y and the x together, and that's this dot right over here. 1, comma 0. Do not put it on the wrong axis. Then my y-intercept, which is always 0, comma c. That's the positive 1, and that was this point right over there. Now, I know that the pink line is the line of symmetry. What other point can I draw on my graph? What other point can I draw on my graph if it's symmetrical? So what ordered pair would it be? 2, 1. It's here. This is the middle. So it's like if you were to fold the graph in half, like this, the other one would be like stamped down. Can you guys all see that? Yes? So it's like if this was the middle, over and up 1, over and up 1. Does anybody remember I showed you guys a special pattern to make the whole parabola? I said you would go out 1 from the vertex, up 1. Then I said you would go out 1 and up how much? 3, you're right. Out 1 and up 3. And then the next one you would go out 1 and up how much? 5. Good, all the odds. So if you really wanted to make it much nicer, you know, you could use that to help you out. It's all the odds. But that's only when a is equal to 1, okay? So there's your parabola. Now, look what it says. Use any technique or strategy you would like. Pretend you forgot these formulas, and I don't think it's a good idea for you to do that because it's actually annoying to do it this other way. If you forgot the formulas and you need to answer a question, right? It's open-ended. You got to answer 8 out of 10 open-ended. What can you do if you're desperate to make sure that you get a graph on your paper of something? What could you do? You have to graph this. I give you an equation. I want you to graph it. What's something you can do? Well, you have to use, it's a parabola. So what's a way to get points on your paper? What's the first way you learned how to graph when you were little? Did you learn to make a table and plug in points? Ever? No? So you plug in 1, plug in 2, plug in 3, plug in 0, plug in -1. You have a calculator, right? Put parentheses around the number you're plugging in. Then you get the y and just put all the dots on the paper, connect the dots if you're desperate. I don't suggest it because it takes a really long time, and sometimes you guys mess up with parentheses, but it's better than nothing, okay? I would say you should just know your formulas. I color-coded here, and you can come back and revisit this later, okay? F12. Next. This is an even easier one, okay? Look at what I'm giving you. The axis of symmetry, so we're going to graph the parabola with the axis of symmetry at -3. What color did I graph my axis of symmetry in the last example? So I'm going to go over here. I'm going to use the same color. Is your axis of symmetry vertical or horizontal, Ovan? Is your axis of symmetry vertical or horizontal? Horizontal is this way? Like the horizon? But let's flip back for a second. Which way is your axis of symmetry?
Oh, wait.
Say it again. It's vertical, yes, it's x value. So x values, -3, vertical line. So I'm going to go over here at -3, and we should all draw a vertical line, step 1. Next, what color did I graph my y-intercept on the last page? Anybody remember? Nafia, do you remember what color I graphed my y-intercept on the other page? Good, it was green. So I'm going to go over here. My y-intercept is at 0, 4. Cairo, how do I get to 0, 4? Which way do I move? How do I go to 0, 4 from the origin? Which way do I move? Up 4. So it's going to be right over here, my y-intercept. I'll put a dot there. What color did I graph my vertex before? Orange. Where's -3, 5? -5. Which way do I move? Avery? Which way do I go to get to -3, -5 from the origin? Left 3. And down 5. Thank you. Right there. I need the reflected point now. We were messing that up just a minute ago. I need that reflected point. How do I get the point that is being reflected? I have this is one side. There's my vertex. Double what? I need to get a look. My U is going to look like this. Well, if I double the y-intercept, that's 8. That's going to be like something up here. I want my U, look at it. It's going to look like this. How do I figure out where the other point goes? I'm just going to trace these lines so you can kind of see. That works sometimes, but we don't know the equation has a 1 in front. So we don't see the equation. We're just given information. So look, here's the pink is the middle line, guys, right? How far is my green dot? 3. So I'm right here. I need the other one. So where do I go? Which way? Yep. 3 to the left. That's it. Do you see I just like flip that over? That's all you do is you flip it over the pink line. Now, is it possible that it follows Cairo's pattern he mentioned? Yeah. We could check. Over 1, up 1. Over 1, up 1, 2, 3. Over 1, up 1, 2, 3, 4, 5. Yeah, it does. Now, that doesn't guarantee that it always will, but if you guys know that trick, it might be very helpful. And that helps you draw a much nicer graph. Okay? Or almost think of it like slope anyway. Think like I go up this much over that much, back to the vertex, up this much over that much. Whatever you need to do. That's it. Done. Okay? That's all you need to do. That point right there is the 0, 4. This point over here is -3, -5. This is the axis of symmetry. The x equals -3. Do you think the graphing of parabola is easier from this or from the other way? Was this easier or was the one before it easier? Because here I'm giving you all the details. Here I'm telling you where everything is and you don't have to figure it out. You just get it plotted. But there's going to be questions, one of each, right next to each other. So if this helps you with the other one, then maybe look at it and use it, okay? So that's number 13. 14 and 15, you guys should be actually really good at, I really hope. What do we do for 14 and 15? I'll leave it a little bit showing, but factoring. So we're going to factor. Is there an equal sign on 14 or 15? No. So are we solving? No. Okay, I need to factor this. Now, if the number in front is 1, 1x squared, you could jump right to the answer. You don't have to fully do AC method, but I know some of you need some practice with that. So AC method, what's A times C for number 14? 45. All right, we have to figure out numbers. I'm going to do it sideways to save room. What numbers multiply to give me 45? 1 times 45. Does 2 go in? 3. 3 and 15. 4. 5. 5 times 9. 6. No. 7. No. 8. No. 9. We're back where we started. Okay, but they have to add or subtract to give me -14. 14, yeah. Which two numbers do I like? 5 and 9, we like these two, very good. All right, I'm gonna slide this up so hopefully people are done. Now, if I need negative 14 with this, then what kind of 5 and what kind of 9? Good, I think you guys are pretty good at this. Now we have x squared. Instead of writing that, we split it up, right? We write minus 5x, minus 9x, and then plus 45. Underline, underline, greatest common factor. What's the greatest common factor? Right over here. Jay?
X.
Good. What's the greatest common factor over here, Josh? This one was the GCF. 9, but we're going to put the negative. So whatever sign is in front of this, that goes with it. Then, again, I'm going to go sideways a little bit. Bring it out front. Bring it out front. Parentheses. Parentheses. So scoot that over. All right. Pretzel. Pretzel. What goes inside? All right. This one, Moreau. What goes inside of the first parenthesis? So it's x squared minus 5x and then over x.
X minus 5.
Good. Nafia, what goes in the next parenthesis? I have negative 9x over negative 9 and positive 45 over negative 9.
X minus 5.
Good. If it matches, you're winning at life. Bring it out front. So I'm going to write my final answer here. So I'm scooting all the way back to here. So what am I bringing out front? X. Well, x minus 5. The thing that matches, I usually put in front. It really doesn't matter, but what's left inside is the x minus 9. Okay? The next one, a times c. So what's a times c of 1 for this one? 15. All right, what multiply? Oh, I should really have boxed the whole thing. What, JR, what multiplies to give me 15? Sure, 1 and 15, and 3 times 5. Out of those numbers, B for but what? But they have to add to give you negative 8. So Nicole, of those numbers, which ones give me negative 8? The 3 and the 5. And what kind of 3 and what kind of 5 do they have to be to give me negative 8? Both negative. So a negative and a negative. So that gives me next step. X squared minus 3x minus 5x plus 15. Underline, underline, greatest common factor. August, what's the greatest common factor out of these two? X. What's the greatest common factor out of these two? Emerson? Negative 5. That is your main weakness, guys. It's forgetting that negative, okay? Pretzel, pretzel, what goes inside? Question? Hurry up. Or actually, bring it out front. Bring it out front. Parentheses, parentheses, pretzel, pretzel. What goes inside for the next step after the pretzel, Jay?
X minus 3.
Good, and then this one is also an x minus 3. If it matches, you're winning at life. Bring it out front, x minus 3. What's left inside? X minus 5. Does order matter? Not really. But guys, again, listen, if it's a multiple choice question, you should be able to narrow down which choices don't make any sense. If you have 2 hours for an exam, you should not take a wrong answer for a factoring question. I don't care if you have to FOIL every single one out. Okay? You got to get these right. All right, next. How is number 16 different from 14 and 15? Avery, how is 16 different noticeably from these two? What is this one going to have with it that these do not? Why is 16 different? Yeah, it has an equal sign. If you have an equal sign, that means you need to do what step of directions, Gabby? If you have an equal sign, you're going to have to do what? Say it again. I'm sorry, I can't hear. Okay, yeah, but because our goal when you have an equal sign is to solve, and you'll do that by setting it to 0. So she says subtract 49, and that's a perfect start. Now if we minus 49 here, and we do a minus 49 here, what am I left with in this equation now? Ovan? X cubed plus 7x equals 0. Now it looks a little funny, but I can factor this. Jahari, how should I start factoring this? What's the first method of factoring you should always check for first? Yeah, is there a greatest common factor? Yeah, so if I take out x, Jahari, what's left inside? Good, x squared plus 7. Now, can I factor x squared, thank you. Can I factor x squared plus 7? It's not a difference of 2 squares, it's a sum. We really can't factor this. But now we're going to go and set everything equal to 0. What happens, what do I write for this part? Yeah, we write x equals 0, which is essentially finished. Now here, I'm just going to go like this to separate my space. And then from there, I went and put the final answer down. I'm actually going to, for the ones above it, I'm just going to go over here and highlight the final answers because I know it's a little squished. Okay, so one answer for this, I got x equals 0. Now what am I setting equal to 0 for the next part, Jeremiah? I set that equal to 0 right there. Now what am I setting equal to 0? We already set this one equal to 0. That's one of the factors. After you get it factored, we set every piece equal to 0. So
The x to the second plus 7.
good. X to the second plus 7. Now that's a little weird. But what would I do next, Nafia, if I'm trying to solve for x?
You add 7.
Well, it's already positive, so
Then you subtract 7.
good. Minus 7 minus 7. So I have x squared is negative 7. Now what do? I'm trying to get x alone. What can I do next, Nicole? I have x squared is equal to negative 7. I'm trying to solve for x. What do I do next? Not divide. What are we trying to get rid of?
The square.
How do you get rid of a square?
Just get rid of it.
Good. We're going to take the square root. Now, when we go and take a square root, what do we have to remember in front every time we take a square root ourselves? When you take a square root yourself, before that, what do you have to remember out front? A certain symbol, because like, yeah, plus or minus, okay? So you take it yourself, you have to remember you'll get then x equals plus minus. Now, I'm still not done. Does 7 have a square root? Like a perfect one? All right, what about this negative? I think I heard someone say something about it. What do we say, Armand? Yes, I. The 7 is the negative. The square root of a negative means we use I. So x equals positive and negative I square root 7. How many answers are in this box I'm making right now? How many? No. 2. Positive I rad 7 and negative. If it's multiple choice, they're probably going to list them side by side. So you do want to watch out for that, okay? So you want to watch out for that. They're probably going to list them side by side. So if I made a list of the answers, okay? So for number 16, your answers might look like 0, comma, negative, I square root 7, comma, I square root 7. Do you see what I mean? Like they'll list it like that in a multiple choice or something. So I think that you could, if you solve it, even if you got stuck somewhere, I think that by looking at the choices, it will help you figure out what to do. All right? If I want to solve by factoring, Gabby just told me I have to get it equal to a certain number first. What number do you have to get your equation equal to before you could solve? Good, 0. So what am I going to subtract from both sides? Good, we're going to subtract 196. 196 is an important number. So I have 64x squared minus 196 is 0. It says solve by factoring. How do I factor this? What kind of situation? Sahai, do you recognize what kind of situation this is?
8x
There's an 8x,
minus 14.
Ooh, good. 8x minus 14 and? Yes, she got it. 8x plus 14, 8x minus 14. That's true. What is this line called? Like really this part of it? What is this thing? It's one of the types of factoring techniques. So it's the difference of two squares. And then Sahai factored beautifully by using what kind of thing? Conjugates, nice. But the question didn't say factor, right? It said solve by factoring. So am I done? No. Next step. What do I now have to do? Say it again. Well, we really said, yeah, each of them equal to 0, right? So 8x minus 14 equals 0, 8x plus 14 equals 0. In both cases, we're going to bring 14 to the other side. Here it becomes positive, but the other one is going to become, well, it reduces. So if it's a multiple choice, you won't find the answer that way. But you definitely leave it as a fraction. You don't make it a decimal. So this will be x equals 14 over 8, but our mom was just asking about it, so I'm just going to write over the page number, sorry. How does that reduce? So 7 over 4, well, this one for me is positive, because that one I did first. And then this one I'll get, what was that, 8, and then x equals negative 7 over 4. So you should have one of each, right? Here's another trick that we did speak about in the past, but I want to remind you. The other trick is, whatever the power is of the equation, that's probably the number of, yes. So here you had a third power, and we have 3 equations, right? Here I have second power, and I have 2 answers, okay? So definitely a good hint. It's not every time, we'll talk about it later, but most of the time. Next one, solve by factoring. I'm going to do this one quickly. You're still writing, and you're going to keep this out. You're not packing up yet. When you walk out, if you want to put it above the red book on that shelf, you can. So here, 100x squared. It's still the same directions. I'm going to subtract 36 equals 0. These are both perfect squares. So we're going to factor like Sahai did before. I'm going to use the square roots of each number. That's 10x, 10x. Square root of 36 is 6 and 6. 1 gets a plus and 1 gets a minus. Here, we set each equal to 0. 10x plus 6 is 0. 10x is negative 6 because I brought that over. Okay? Just drawing an arrow. Then x equals negative 6 over 10, which reduces to negative 3 over 5. And then that parenthesis, drawing my arrow, 10x minus 6 is 0. 10x equals 6. X is 6 over 10, but 6 over 10 equals 3 over 5. So winner, winner, chicken dinner. Here's my 2 answers again, and I had a second power. All right. I know I have 2 answers, but here's a trick question. This is what I was warning you about, okay? What is the number of real solutions? What kind of solutions could you have? If they're not real, what else are they? Right. So we might have imaginary solutions here. So we could try to solve by factoring. If factoring doesn't work, what are you supposed to do? What's it called? Factor and solve, or use the quadratic formula. All right, what is the quadratic formula? Quadratic formula. I sang it to you. X equals
Plus or minus
a negative b plus or minus.
b squared minus 4ac over 2a.
I need you guys to say it a million times to yourself. Okay, oops, sorry, I was cut off. Now, ready for a shortcut? We're going to get this ready to factor and solve. How do I get it ready before I could do anything to it? What should we do first? What do I need to do to number 19 before I can really factor and solve anything? It's not in the right position. What do I have to do to it, guys? Add what? Good, we're going to add that 4x to both sides. That's going to be my middle term. Everyone sees that? It's the x term. So I'll have what as my equation? 2x squared plus 4x plus 2. And this is where I will continue with you guys tomorrow. All right, we left off talking about this example here. And the question has these directions. It says, what is the number of real solutions? One of the first things we did in the school year is we also dealt with a special type of number where it's not a real number, it is an imaginary number. And you even see, if you look up at the next question, we have imaginary number stuff right underneath it. And imaginary numbers, I think you guys thought those were pretty easy. So I'm not going to take up too much space of the imaginary number section. I'm going to kind of like really give this room for this question for number 19, okay? Because we could do it a couple ways. Now, when you look at this, can you guys all recognize that this is something you should factor and solve? Can we all look at that and see like, oh, this is a factoring question? Yes? If you know it's a factoring question, what number do we try to get it equal to? 0. So I added the 4x, but I put it in order. So that's what got me this step right here. So everyone got this written down? Sam, you're good? Okay. Now, if I try to solve this, there's a few things we can do. You guys see when you have an equation and there's a common factor, you can actually reduce everything by dividing everything by what number in this case?
2.
Yes. If you divide everything by 2, the good part is because I have it equal to 0, 0 divided by 2 is 0. So we're allowed to do that. But let's pretend that we don't know we can do that. I'm going to leave it 2, 4, and 2, okay? Now, if you try to factor this, you're going to do AC method, and you're going to do 2 times 2 is 4, and we can try to factor it. Factoring does work on this question. However, if you get stuck factoring, we can use quadratic formula. So let's do factoring first, and then I'll show you the quadratic formula trick. What kind of factoring method do you always try first? You guys are pretty good about remembering. Good, GCF. What is the GCF? 2. So I'm going to take the 2 out front. What's left inside, Armand, after I take the 2 out front? X squared, what else? Plus 2x, I'm just going to take a plus room there. X squared plus 2x plus 1, good, equals 0. All right, so I'm just closing that quadratic formula up right over there. We're here. Now, if you do AC method, I'm going to do 1 times 1, AC, equals 1. What multiplies to give you 1, but adds or subtracts to give you 2? 1 and 1, perfect. So I'm going to split that up to 1 and 1. 2 stays. I have the x squared plus, what do I write instead of 2x? And another. Good, plus 1 is 0. Underline, underline, greatest common factor, which is x, and plus 1. Then this is where, and someone always asks me, why are you using brackets? Usually it's Armand. And I'm going to use a bracket. It's true, right? Like you guys know, he's going to ask. So I'm using a bracket because I'm going to use parentheses here so I could have layers of marking it up. bring it out front, parentheses, parentheses, close the bracket, here's the 0. Yep, I heard pretzel. So that reduces each of my pretzels. Yep. So you guys are getting better, I think, at factoring by this point. I think you're pretty good, but don't get overly confident. Make sure you practice. So I should get x plus 1 and x plus 1. If it matches, it does. We're winning. So we bring it out front. And what's left inside? Now, this is a special example. Do you guys see how I got 2 of the same factor? If I solve, what answers will I get? So I get the same number twice. Can everyone see that? I would get -1 and -1. I set each of these equal to 0, and they both give me -1. So how many solutions do I actually have? 1. When you have the same number twice, we say you just have one answer, right? So it's like, oh, who's doing this? Jahari. Okay, well, who's doing that? Jahari. So it's like one person doing 2 different jobs. It's Jahari, okay? Like, that's it. So if I get the same number twice, what answer am I going to circle? Now, how could you know it faster? When you start factoring and you get the same thing twice already, you could already circle one solution. You know it's done, okay? If I factored and I got like x plus 2, x plus 5, well, I'm going to get 2 solutions then, right? I have 2 different things. If it's not factorable and we have to look at the quadratic formula, this is where this other method comes into place. This is the plus minus in the quadratic formula. That's the part responsible for the 2 different answers, right? You remember when we did that worksheet, you did this number plus something over a number, and then you did this number minus something over a number. Do you guys remember that? Jeremiah M? Do you remember the worksheet with the quadratic formula, and then you had to write it twice, right? One with the plus and one with the minus? So that gave us 2 answers. What would happen if this b squared minus 4ac ended up equaling 0? What would happen if the b squared minus 4ac, Sam, if that ended up equaling 0? You would get negative b plus, what's the square root of 0? And if you add 0, or subtract 0, do I get 2 different answers? No. You get how many answers? Just, no, 1, because you get negative b plus and minus 0 is nothing. It's the same over 2a. So here's your trick, ready? I'm going to write the trick down here. Shortcut. B squared minus 4ac. That part of the quadratic formula. It has a special name. This is called, I'm going to write it up here, the discriminant. Sorry, I'm squeezing that there. It's called the discriminant, so it kind of sounds like discriminate. So it's like, basically, it's discriminating against types of answers, okay? So if b squared minus 4ac equals 0, that means 1 solution. So that's just a shortcut. If b squared minus 4ac, now these are the other 2 options, equals a positive number. Can you take the square root of a positive number? You can't? What's the square root of 4? Yeah, so what's square root of 9? So if I had like plus 3 and minus 3, wouldn't I get 2 different answers? So if you had a positive, we write that we have 2 solutions. And what's the only case left? If b squared minus 4ac is, what case did I not talk about yet? Negative. If it's negative, well, can you take the square root of a negative? What's the square root of a negative? I. And is that real? No. So you just write 0 solutions. It's 2 imaginary solutions, just you don't have any real ones. That's why the question even asks how many real solutions, okay? So how many do we have for this example? 1. How do you know you have 1? When we factored it, we had the same factor twice. That's why, okay? So this was just a little trick on the side, okay? It's all recording, so it's all going to be connected in this video. But we could solve by factoring, and if factoring doesn't work, you use the quadratic formula. Are you going to memorize the quadratic formula? Yes. Okay. The answer is yes. All right, next problem. Let's go around and around. So, Moreau, simplify the expression. We're just going to add this up. So if I go to add this, what do I get for my next step? Do I really need the parentheses, Moreau, to add? No. So let's get rid of them. -1 plus 2i plus 2 plus 2i. I add those up. So Moreau, combine like terms for me. What do I get?
4i.
We get the 4i because of 2i and 2i.
And
1. So it's 1 plus 4i, and we're finished. Was that one easy? There's going to be one like it. So can we get that right? Thanks. Nafia, if I have a minus this time, what do I have to remember to do? So this one's just a minus in front of a parenthesis. What do we always have to remember to do when we have a minus in front of a parenthesis? Yes. And then we all say that we're going to distribute, and then I check your work, and you didn't distribute. So Nafia says we need to distribute. So Jahari, what should I write for the next line? Good. Plus 2 plus 2i. A lot of you would still keep that minus. It's not even distributing, right? Here's another question. Jay, what do you think, like look at how these have parentheses on them, right? What do you think people do by mistake all the time when they see these? Because of the parentheses. Not add. What other thing, when you see parentheses around stuff like this, what do you kind of want to do? Yeah, who said it? Good. Foil. And if you guys have what you're going to say? Yeah. People want to foil. When do you foil? What number on this page would you foil for? 23 and 24, yeah. Okay? So at the bottom of the page, yeah, mine's just cut off. Okay, so Jeremiah M. Jahari got us set up. We wrote this out. What's going to be my answer when I combine like terms?
1
plus 3i.
Yeah, 1 plus 3i. Sorry, Jeremiah M. soon. All right, done. This one's just like it. Avery, distribute that negative for me. Tell me what the next line will be. Oh, so you're saying a positive 2 and plus 2i. I'm just going to do the beginning part though. 1 minus I. So make sure when you make i's and 1s, you make your dot really heavy on the I, and make the 1 Armand, and make the 1s not just lines, like a little heavier on being a 1. All right, let's combine like terms. Sam, what do I get for the next part?
You would get 3 plus I.
Good. Just because things are multiple choice sometimes doesn't mean like you should like halfway do the work and guess the answer. Okay, take your time. It's very easy to just impulsively get distracted by something and pick the wrong choice because you're overconfident, and I would like you guys to all get good grades, okay? All right, this one here, 23, JR. We just said for 23 that we want to foil because these are 2 back-to-back parentheses, so foiling is definitely more our speed this time. So can you help me out and get this foil started? First times first is 36. What about outer?
6I.
Good. Inner? Nice. 30i. Last times last. I'm on. 5i squared. All right, he did a good job. Ovan, what can we combine? To get what? Okay, and Ovan, can I do anything with this? I'm sorry, I couldn't hear you because Armand can't sit still. Good. Does everybody remember what I squared equals? I squared is?
-1.
Yeah, I know you know. Okay, so our Ovan is saying to switch I squared into -1, and we all should know what's 5 times -1. Good. So I'm showing a lot of work here. You might not need to show as much. I'm just really listing it all out. So next step, Ilsa, 36 plus 36i minus 5. And what do I get?
31 plus 36i.
Done. That is it, and you're finished. Okay? Emerson, let's get this one foiled over here. First.
20 plus 8I plus 15I plus 6I squared.
Good. So, Passion, what did we just say I squared is equal to? Good. So we're going to change that into -1. And then this whole thing will become? Good, -6. So that's just this work. Over here, Josh, what do my middle terms combine to? Nice, 23i. And I'm just going to rewrite it. So from there, I have 20 plus 23i and -6. All right, Armand, your turn. Final answer?
14 plus 23I.
Good, 14 plus 23i. How do we feel about this page overall? Good? Okay. Over here, let's rewind for a second. This one, we factored it. It was a difference of 2 squares, right? We factored and we solved. When you take a square root, remember, you want to put plus minus. Here, we factored and solved. We just were asking how many answers there were. With the same answer twice. That means it's really just one answer, one real solution. Okay, around we go. So hi. What's the square root of -4? Oops, sorry, I'm cut off. My bad.
15.
Square root. See the square root symbol, you gotta go the other way. I didn't ask you to square it. If I asked you to square -4, that means to do -4 times -4, right? That is equal to 16. That is the square, so I'm gonna write this out with words. The square of 4 is 16, right? So the square of 4 is 16. But this, the square root of the square root. That big word root, roots are where you come from, the square root of -4. So I'm just going to draw a line to separate that. Okay, I like that Cairo also just asked about the plus minus. When do we use plus minus? It's when you are the one taking the square root yourself. If the square root's already there, you don't need to put plus minus. So, that being said, Sahai, what's the square root of 4?
Plus.
No plus minus because we're not taking it. The square root was already drawn on the problem. If we put it there, I'll show you an example. X squared equals 4. If you are solving this problem, then you're the one that comes in and draws that. That's when you're going to do plus minus 2. But here, it's already drawn. Well, the I is for the negative, and what's the square root of 4? So the final answer, 2i. So the negative turns into what? Okay, good. And the rest is just you treat it like normal. Okay? Here, square root of -49. Cairo? That's it. Are we all okay on this? Next. Use graphing or substitution to find the solution to the system of equations. Now, we've been talking about systems of equations for a long time. A system of equations, we usually use which methods to solve? There were 3.
Elimination, substitution. Graphing.
Good. Graphing, substitution, and elimination. Those 3. This has to use these 2. We don't really want to use elimination here. Substitution is actually pretty easy for this one. So I'm going to talk about both of these in 2 different ways. If I use substitution, do you see how we already know what y equals?
Yeah.
Everyone can see that? Here's y, right there, and here's another y, right there. But I know what y is equal to because y is already alone on one side of the equal sign. So I want to substitute in this example and get y plugged in to the other equation. What can I write then for the next line? I want to fill it in. I see that y is equal to this. I want to take this and fill it in. So Josh, what can I write?
You can write x squared minus 4x.
Well, it's, you're already ahead of step. Go back one, showing the whole work. You're right, but because you got 4 by doing work, right? So it was a line really before it. Like you're going to take this orange thing, because that's what y is equal to this, and you're going to plop this right into this. So don't combine like terms right away.
So it's x squared minus 4x minus 8 plus x equals 2.
Don't know. We're just subbing this. See the thing I circled up here? All right, everyone kind of see this because I don't want you to make the same spot. This is what y is equal to, right? So it's like, so, you know, you play a certain position, you get hurt, but someone else also plays that position, you put them in your spot. Yeah, the backup. So y's backup is x squared minus 5x minus 2. That goes here. X squared minus 5x minus 2. That went in for y. I don't really need parentheses. I'm just putting them. Plus x equals 3. Good. So I took that and filled it in there. You might have the next line, Josh. I think you already had done more work. You said x squared minus 4x. And then you said 8 or something. Or another number. Are you looking at the example below it?
Yes.
Okay, I was like, where is he getting these numbers? I was so confused. Okay, there we go. You were looking at the one under it. So you were looking at number 28 by mistake. There we go. I was like, what does he look? So Josh, I thought, because minus 4x, if you look at this step, Josh, that's negative 5x plus x is negative 4x. So I thought you already were doing work in your head. That's why I didn't notice you were doing the next one. All right, let's combine like terms. So Jeremiah M, what do I get for the next line if I start cleaning this up?
Huh?
What do I get? Look, you gotta, don't zone out, okay? I'm showing you literally how to do every question in this review packet. This study guide is exactly like your midterm. I'm doing everything with you right now, okay? Don't zone out. Promise. Try. X squared minus 5x minus 2. I put that in. I'm using substitution. I fill it in there. I wrote this out. What can I do next?
You can factor.
Not yet. We gotta get it all cleaned up. All like terms combined, and we have to get it equal to 0 first. So do you have any like terms over here?
No.
Yes, we do. I don't need these parentheses. It's just addition. Look again. On the left side of the equal sign.
Oh, you did negative 4x.
Good. Negative 4x. So that took care of this and this. And I want to bring that 3 over there too. What would I get?
Negative 5.
So we had negative 2, negative 3 is good. Negative 5 equals 0. Good. Now all I'm going to do is I'm just going to highlight this just because I feel like it's a little messy. Not really. My highlighter's running dry. Okay? So that's what I'm working with now. What can I do at this step, just looking at what we have, I think you have pretty good instincts. We want to solve. So Morel, what can I do with that? X squared minus 4x minus 5 equals 0. Yeah, we could factor using AC method. So A is really equal to 1. AC then will equal negative 5. Nafia, what multiplies to give me negative 5? B for but what? But adds to negative 4.
5 and 1.
So 5. Well, I need them to add to give me negative 4. 5 and negative 1 will give me positive 4. So,
1 minus 5.
yeah, so it's positive 1 and minus 5. Good. Now, Armand, what do I do with those numbers to set up my next line of my...
Plug them in and put them in.
Okay, can you tell me what to write?
X squared plus x minus 5x minus 5.
Nice. Equals 0. Then we factor by, what's the name of this method? Anyone? Grouping, good. Sahai, what's my greatest common factor out of these two right here? Good. Avery, what's my greatest common factor out of these two here? Well, it's got to be? Yeah, okay. Please all try to remember that. Negative 5. Now, I know it's a little squashed here, so I'm just going to draw a red line to separate me from my next problems, and I'm going to use the space up top here. I'm just going to draw the arrow. I'm going to go around. So let's box this off so this works separate. I'm just going to take this over here. That means you bring it out front. You bring it out front. Parentheses, parentheses, pretzel, pretzel.
Y goes inside.
So x squared over x is?
Bring it out front.
Not yet. We already did that stuff.
X plus 1.
Good, x plus 1. And do I get another x plus 1, Jay?
Yes.
Yes. But Avery, when you just said 5 on bottom, if we just put 5, we'd get negative x minus 1. So that's why you always got to make sure you put that sign with it. I know I have that GSE still written. I'm just going to erase that. That was for graphing, substitution, and elimination.
If you do, if it matches, you're winning at life.
Right. If it matches, you're winning at life. Bring it.
Up front.
Here's the x plus 1. What's left inside is?
X minus 5.
Good. So we're almost done. So if I set, what do you do next? You really? What do I do with that?
You said we're going to do 0.
Like this. Good. And then I get x equals negative 1, and then I do this one next to it, not under it. Now, these are not your answers, though. We are solving a system. How do you get answers with a system? They have to be written as what?
Forward pair.
Good. So I only have x values of my ordered pairs, right?
You have to plug that back into an original equation.
Which original equation would be easier to plug them both each back into? Yeah, I would say that one. So if I put in negative 1, what does y equal? If I fill in negative 1 for x, what does y equal? Add 1.
Oh,
4. Were you guys trying to figure out what plus negative 1 is 3? Right? Add 1. 5. If I fill in 5 for x, what does y equal? So subtract 5.
-2.
Yes. Okay, so here's the thing. If this is a multiple choice question and they solved by graphing, that means you have to look at it from a graphing perspective. All right, recording. So here's another example. I'm going to quickly do this one. You do the same thing and you solve your system. So I'm just going to quickly do it. X squared minus 4x minus 8 is going to get filled in because that's what y is for y right here. So next to it, plus x, that's that, equals 2. I'm going to combine like terms, all right? So this went in for y. That's what that part is. Plus x equals 2. I'm going to combine like terms. If they're already on the same side of the equal sign, we're good. So that's x squared minus 3x minus 2 gives me negative 10 is 0. Then I get, if I factor by AC method, I'm going to just give you guys the factored form because I showed you a bunch already. We'll do other ones together. You should get x minus 5 and x plus 2. After that, you set each equal to 0. That gives you two different x values, which is good. That gives me x is 5, and that gives me x is negative 2. We're not done. I have to get some ordered pairs. So if I go right there, and I fill in 5 for x, y plus 5 equals 2. Subtract 5, and I get that y equals negative 3. That means my one answer is 5, comma, negative 3. Then I plug in 2. Y plus 2 equals 2, and that gets me that y equals 0. So, oh no, it's not what I wanted to plug in, right?
Nope.
Negative 2. So that gives me y equals, I'm going to add 2 to the other side. So I get y equals 4. So that gives me negative 2, comma, 4. So those are my two solutions. When all is said and done, the choice, if you had to do it by graphing, you should have a parabola that's opening upward, and it should pass through these 2 points. So there's one of them in one spot, and then we'll have one of them in another spot, and then we should have a line matching there. So whatever the graph looks like, make sure you just find the right answer. All right, next question, 29. What should I do for number 29, Jay? I want this in standard form. Let's pretend the directions were not even written in English. All right, Jay? If you just had this in front of you, the math part, what do you want to do?
Distribute.
Then do it. You're right.
Okay.
Trust your instincts, guys, okay? So what do I get?
For the 3x to the 4.
Careful, it is x to the 4. But when you distribute, what operation are you doing?
Multiplication.
What number's in front of x squared?
1.
What's 1 times 2?
2. So it's, okay.
All right, everyone? There's 2x squared. Now, next term, keep distributing. What do I get for the next term, Sam?
What?
Use context clues. Look at the board.
5 and 2.
Now, is this in standard form yet, of 1? What do I have to do? Right. Why is he correct, Ilsa? Why does 5x to the 5th go first? Because it's what? Larger, right. You put it in what we call descending exponential order. You should have your biggest power first, and we should also have all like terms combined. That's it. Is this an easy question or what?
That's fantastic.
That is literally it. But that's the thing, because see how easy it is to mess up? Here, do you multiply your exponents or add them? And then you multiply the coefficients. So let's do an example on the side before I move on. X squared times x to the 3rd is x to the 5th. What about x squared if I cubed it on the outside? That's x to the 6th, yeah, okay? So just a couple things there. All right, next. Here, okay. Algebra 2 is almost always going to come down to you factoring and solving. That's literally a huge chunk of the content. I have these examples here. Does anyone know, you're gonna have a calculator. So AC method. I know it might not look like AC method, but as long as this power, if this is double the middle power, you could do AC method. If it is double the middle power, then use AC method. Okay? So, if you have a calculator to help you, that's cool. Bring one to the exam. However, right now, it would be nice if someone had one. What multiplies, so 1 times that, what multiplies to give you 324 and adds or subtracts to give you negative 45? Yeah, whatever. I mean, come on, there's more important things to think about. Yes, you're right. What multiplies to give you 324? Who has a calculator? A couple of you do. There's one behind you. JR, Sam, they're on the wall behind you there. Emerson, Ilsa, they're on the dry erase board over there. Ilsa, there's actually one like right behind you, kind of. On the ledge. Come on, grab it. Help me out. 324. Get off your butts. Get a calculator. Come on.
162 and 2.
That doesn't give me 45, so let's try it again. I think one of the numbers is 18. Maybe not. 9?
81 and 4.
Ooh, I like 81 and 4. But does that give me 45? No. How about 36?
No, it has to be 41.
9 and 36? All right. 9 and 36. Emerson found it. What kind of 9 and 36, if they multiply to be positive and they add to be negative? Yes, both negative. All right, that gives me x to the 4 minus, how do I write my middle term though? It's not 9x, it's 9. Look at the middle term originally. Good, x squared minus 36. 36. X squared plus 324. Again, you'll have a calculator and the numbers will be a little easier, okay? It's a review packet, so we gave the bigger numbers, okay? Next part. What's my GCF out of the first 2 terms? What's my GCF for the first 2 terms, Armand? X squared. You're writing this down, right? Because I'm collecting this packet from you, so. X squared. What's my GCF, JR, out of these 2? Negative 36. Yeah, because 36 goes into 324. We just said it was 9 times 36. I'm going to bring it out front. Bring it out front. parentheses, parentheses. Now, after we do the pretzel, what's left over here? What goes in this parenthesis? Anybody? Thank you much. X squared minus 9. And what about in this one? Perfect. All right. This one's a cool example. I know I wrote really big. I'm just going to scoot over a little bit. But the GCF that I'm going to pull out front right now is x squared minus 9, right? They both have it. It matches. We're winning at life. So I'm just going to box off my work here for a second. So that comes out front. X squared minus 9. Sahai, what's left inside when I take that out front?
Wait for
So I just took x squared minus 9. I had 1. If it matches, you're winning at life. Bring it out front. Then what's left next to it?
X.
So this crossed out again.
So think the line.
What line? If it matches, you're winning at life. Bring it out front. This is out front right now. I factored it out because they both had 1. Then what's left?
X squared minus 36.
Yes. Now, if you look at this, you guys, can we factor this?
Yeah.
Sam, how does this factor? No. How does it factor? How does it factor? Ovan, what kind of thing is this? How does it factor? It's a difference of 2 squares. Difference of 2 squares. And how do we factor this particular difference of 2 squares? X? X plus 3 and? X minus 3. And what about x squared minus 36, Cairo? If x squared minus 9 just factored to x plus 3x minus 3, how about x squared minus 36? Good. I'm just squeezing. X plus 6x minus 6 equals 0. I got to finish this. How many answers will I get, Avery? Nope, look at it. We started with these 2, but they each turned into 2 more parentheses. We're going to have 4 answers. My 4 answers will be what, Jahari? Right. So I could write it like this, plus minus 3 and plus minus 6. Or, like Jahari even said, we could list it. Negative 3, positive 3, negative 6, positive 6, whatever. That's the full list of answers. So that's number 30. 31, now look at the shortcut for this though. We said, because that's a 1 in front, we said the numbers we used are 9 and 36. Do you see that those are in my parentheses? So those of you who know the shortcut for factoring, the numbers you'll get for this part, we only need to do the grouping part if the first term doesn't start with a 1. So I'm going to do it the cheap way in this one. If you don't understand the cheap way, then don't do it. So number 31, what multiplies to give me 100 and adds or subtracts to give me negative 29? Good, I heard negative 25, negative 4. Josh, you want to say the same thing? So that means I could go right to this step. X squared minus 25, x squared minus 4. I went straight to that step. How do I factor the first parentheses, Jeremiah M? How do I factor this first set of parentheses?
X plus 5, x minus 5.
Good. Nafia, how do I factor my second set of parentheses?
X plus 2, x minus 2.
Perfect. Emerson, what are my answers for number 31? Positive and negative 5, we'll get 1 of each. And? 1 of each. Good. We'll get a positive and negative 5, and we'll get a positive and negative 2. Now, what was the biggest exponent in number 31?
4.
And how many answers did we get?
4.
Good. 30, same thing, right? Biggest power is 4, and we got 4 answers. That's not all the time, but a lot of the time, okay? What do we recognize? What do we recognize? I want you to think real hard with your good brains that your parents gave you good genes, okay? You guys have good brains in your heads. Take advantage. What do you recognize from number 32? What is that? We learned it earlier in the year. I know you guys know it. I know it's there. Dig for it. Okay, see? Now listen, Nafia tried. She started to say perfect squares. As it came out of your mouth, you fixed yourself, right? And you said cubes. You caught yourself. You guys, the more you participate, I know some of you are more reserved, shy, don't care enough, but the more you participate, okay, and do a lot of research for grad school, you will be wrong before you're right. So she fixed herself. When you sit there quiet and it only makes sense as you watch it, that's why you struggle doing it on your own. I know a lot of you guys have played sports or play sports. It's the same thing. Even video games, even an instrument, right? You don't know how good you are until you've been bad at something, right? Like if you've struggled and you were terrible and got better, you know. So guys, by participating it helps. So she was a perfect example. She said it. She took a risk, got to risk it to get the biscuit. She took a risk and she messed up a split second. She fixed it. She said cubes, perfect cubes. What do we use to factor this?
So,
Yeah, we're going to use SOAP. What do I always tell you to do first for these problems? Put on your, not a thinking cap, glasses. Your glasses. Look what I built on the wall for you on that poster. I built you cubes with little 3s on them. Do you get it? And there's a plus minus sign between them.
so they're cubes.
Yeah, they're very cubey. So you have the sum and difference of cubes, and I didn't want you to get too confused with the cubes, so I put little 3s on the cubes. Those are your glasses that you would walk around wearing to see the cube roots. What is going in this parenthesis right there? Can someone help me? 3 what? It is 3x. So you're asking yourself, what is being cubed to get 27x cubed, right? So one of the answers is 3x. Then here, what's being cubed to get 125? How do you guys feel about how good you are at cubes? Do you think you know them pretty well?
Basic ones,
What about 343? What's the 7? 216? 64.
4.
There was the wrong and then right experiment again, right? You said it, you fixed yourself immediately because you heard yourself. It felt wrong. Your brain knew. As it came out of your mouth, it was wrong. Okay? This is like brain power right now. What about 27?
Right.
What about 8?
Yep.
How about 125? 5. Good. 343? 1000? 1221. See, why do you think you know them pretty well? And I made you do them like a million times on those quizzes. That too. Come on. That's called, and I talked about that earlier in the year, and I'm going to mention it again. That's called fluency, where like you can answer something quickly and correctly, and it helps your self-esteem in math. All right, from here, who remembers what to do next? What did I draw next? The pencil's in your hand, and you're trying it. What's next? I draw. No more, well, kind of. You draw. Everyone's favorite line of the song. What goes inside, well, parentheses. What goes inside this one? Does anybody remember? I heard it. Nice. 3x plus 5. Then I took my fairy dust to get these. Do you remember I tapped the pen? What's 3x? Yes, you do. Look, 3x times 3x. That's what goes here, right? Then I did 3x times 5, I got. And then I did 5 times 5, I got. Okay, what's the SOAP stand for? Same, opposite, always plus. Now, this is what we're going to continue with tomorrow, or the next class. This is not done. We have to solve. This is quadratic formula. It's not factorable. We'll get 2 imaginary answers every time with SOAP and 1 real. So we're going to go over that next class. So you should have done up to 32. That means we have about, well, not done. We have about 13 and a half more questions. Thank you for your cooperation. Okay, so here, the directions. When you don't have directions right above a question, if you want to know what they are, what you're going to do is you're going to look above on the paper for the bold directions, okay? The bold directions apply. So it says, what are the real and or imaginary, remember we did imaginary numbers, solutions of each polynomial equation shall all work. So we already did 30 and 31. We started this one, but I'm just going to restart it. This is a polynomial equation. It's a special type. What type of polynomial equation is this? JR, do you know what kind of this is? So on the board, there might be some hints. So it could be a difference of 2 squares. It could be a sum of or difference of 2 cubes. Nafia, do you know?
Is it difference of 2 cubes?
Well, difference means subtraction. So this one is a, yeah, so this one's the sum of 2 cubes. Now, what do we use as a handy helping technique when you factor the sum of 2 cubes? What was the thing, what do we call it, Jay? We put on glasses, that's one thing, so we could kind of think of it that way. And if it's cubes, cubes means what power? So to the third, it was sum, so I'm going to keep the plus sign in the glasses. And then there was something else we used, like another, like a mnemonic device, Armand. So what did SOAP stand for? Same. Yeah, plus or positive, same idea. Okay, now we get started. So step 1, we put on our glasses. The glasses are going to give us x-ray vision, and we're going to see what is it that made this into what it is. What cubed to make us this expression. So what is it that we raised to the third power to get this? 3 what? Just 3? Yeah. All right, what about this one, Jahari? What makes this number that we would cube to get that number? gave you a bunch of quizzes to practice your perfect cubes. So you got to brush up on those because those were also part of your midterm review. So if you didn't do it yet, that's why. So hi. 5, good. 5 times 5 is 25 times 5 is 125, okay? So there's only so many perfect cubes, so let's do a couple. 1 cubed is, 2 cubed is, 3 to the third means 3 times 3 times 3. 4 to the third is 64, which I feel like confuses people. That one's a sneaky, tricky one. Okay, they're just solar powered, Gabby, so when it's dark in the room, they don't work that well. There's that one on the ledge is a little bit better, the black one. And then maybe one by Moreau's head over here too. All right, and 5 to the third is 125. And let's even do 2 more. Who knows 6 to the third? 2, what did you say, Yvonne? Yeah, 216. 6 to a power always ends in a 6. 7 to the third, we'll stop there. Yeah, that's one I feel like everyone remembers that one. Okay, now I have my glasses on. That's really the first step. I just did it right over here. Then we're going to have a linear factor, so a binomial. And then we're going to have a bigger one, a quadratic trinomial. It says equals 0. I cannot just throw it away. It's still there. Okay? Now, what goes in the little parenthesis? Good. You just drop the 3's, and we just write 3x plus 5. Good. So you drop your little exponents. I save those for making my dots later. I'm going to make 3 dots and 3 dots, so I'm going to ignore these and put it in here. Now, to get my 3's back, what's 3x times 3x? That's how you get this term. Then I go here, what's 3x times 5? That's the middle. And then what's 5 times 5? Good. Same means this sign is the same as the original problem. We're good. Opposite, so it's a minus sign. Always plus. Now, here's a couple pieces of advice. When we're solving this, you're going to solve by setting each part equal to 0. Here you have a linear part, 3x plus 5. And I'm going to set it equal to 0. Subtract 5 from both sides. That's not so bad. 3x equals negative 5. Then I divide by 3. That crosses out and divide by 3. Some of you guys get lazy with your work, and then you write this answer in the next step upside down. Like you put the 3 on top. So be careful. Don't do that, okay? So that would be x equals, this is fine, negative 5/3. Now, for this next one, this is a quadratic trinomial that we have to solve, and you would normally try to solve this using what method? Normally, you would try to do what? AC, you would try to factor. Right, so we're going to try to solve by factoring, but the thing is, anytime you have a question that's either the sum or difference of 2 cubes, I promise you, this is not factorable. When their quadratics are not factorable, you're supposed to solve using something else. What can we use to solve quadratics that are not factorable? Quadratic formula. Now, I promise you've got to know what the quadratic formula is, okay? If you don't know what the quadratic formula is, you will struggle and get stuck and straight up not be able to answer this question. So, quadratic formula starts off with x equals, and then I have a big numerator here. What's in my numerator? Negative b plus and minus the square root. No.
B squared minus 4AC
Over 2a. Okay, good. Do we all know what a, b, and c are in this example? Okay, so nice and slow. You will have a calculator, but you have to punch things in the calculator correctly. Some of you guys have you try to break it up into too many steps, and you're making errors, so you've got to practice this on your own. That's why I'm going to give you another review packet of problems to try. Negative b, what am I going to fill in? 15 plus minus square root. Okay, well, what is 15? Negative 15 times negative 15 is 225. Make sure if you do negative 15 squared in your calculator, you have to do this. Okay? Otherwise, it's going to be wrong. Yeah, because otherwise it's going to do negative 15 squared, which means negative 1 times 15 squared, and it'll give you negative 225 if you do that. If you do this, you'll get positive 225, so it makes a difference, okay? Because the operations mean different things. Minus 4. Now, to save a little time, we can try to do a times c all at once. Do you guys know what 9 times 25 is? Think about it. If you had 9 quarters in your pocket, how much money do you have? Good, 225. All over 2a, 2 times 9 is 18. Now, a lot of the time when we do quadratic formula from here, you're going to get some pretty gross numbers. We'll live. 225 times 4. Well, what's 200 times 4? That's 800, good. 25 times 4 is, so 800 and 100 makes 900, right? So I have 15 plus minus the square root of 900, negative. No, not even. 225 minus 900, right? Sorry, distracted. So 225 minus 900, and you guys are allowed to use a calculator, so if you have one now to help me out, that'd be great, over 18. 225 minus 900, well, 200 minus 900 would be negative 700. So 225 would be negative 675. Am I right?
No.
Yes, no? Don't say no unless you have a calculator and check it. Plus or minus negative 675 over 18, right? Squeezing that there. Now, what I'm going to actually do, I'm just going to slide this card up. I'm just going to write on the back another one, taking up a bit of room. So I'm over here. It's okay I cut that off for now? Go here. Okay. Now I'm here. I have a negative in my radical. I think we know what that means. What does it mean? What do you have to write when you have a negative in your radical? What definitely comes out? I comes out. Now the 675, when we simplified radicals, if you remember, we did a factor tree. 675, well, it's definitely 5. Can we let Avery back in? It's definitely 5 goes into it, or 25 goes into it. 25 goes into 100 4 times, so it goes into 600, 24, 25, 26, 27. So it's going to be 25 times 27. So 25 is 5 times 5, and 27 is what? 3 times 3, right? 3 cubed, we just said, is 27, all over 18. Do we remember how to take numbers out of your radical? How do we take stuff out of the radical? Anybody remember how you decide which ones can come on the outside? Yeah, if it's in a pair. So 1 5 comes out, 1 3 comes out. That gives me 15 plus minus 5 and 3 came out. So what do I write outside? 15, because you multiply them. The I is already there. Square root of 3 over 18. This is a lot, right? Now, we reduce this, right? Does 15 and 18, do they have anything in common? 3. If I cancel a 3 out of everybody, not this, but here, here, and here, what do I have left here? 5 plus minus 5i, radical 3, all over 6. That was probably the easiest step, right? Reducing. This, nightmare.com. Terrible. No good. This, last step, fine. How many imaginary answers did you just get? No. The plus and the minus means 2. 2 different ones. That's 2 imaginary and 1 real answer. All right, for this one we're going to solve, so we're going to factor it first by putting on the glasses. Something cubed minus something cubed is 0. What's being cubed to make that is x, and what's being cubed to make that 3. Then I make my parentheses to factor, and I have a binomial and a trinomial. To get the binomial, you ignore these 3's. That gives you x minus 3. Now to get my trinomial, I do x times x, which is x squared, x times 3, which is 3x, 3 times 3, which is 9. Then my signs. This one's the same as the original. This one is opposite, and this one is always plus. And I keep equals 0 there. Armand, did you work that one out all the way already?
Yeah.
You're lying?
33.
No, Armand, the one I asked you to work on.
Yeah.
Do it. From here, I'm going to solve this. I set this equal to 0. Oops, I didn't need to write that. X minus 3, we're going to set that equal to 0. This will give me a real answer. 1 second. That's x equals 3. Now for this one, I have to use quadratic formula because, like we talked about, it's not factorable. So I would do x equals negative b plus minus square root of b squared minus 4ac. This is the regular, good old-fashioned quadratic formula, all over 2a equals. Now I fill in negative b, negative 3 plus or minus the square root. B squared would be 3 squared, which is 9, minus 4. 1 times 9 is 9, all over 2a, which is 2 times 1. Next step, x equals negative 3 plus minus the square root of. Ooh, I was cut off before, sorry, I didn't realize. The square root of 9 minus 36, all over 2. Negative 3 plus or minus the square root of negative 27, all over 2. 27, that's 9 times 3, which is 3 times 3. And I have a negative. The negative is I, pair of 3's. One of them comes out. x equals negative 3 plus or minus 3i radical 3 all over 2. So I got my 2 imaginary solutions and my 1 real solution. Ooh, roll zoom down. Okay? And that's that. When you divide anything by something else, when you were a kid, you learned how to do long division. Long division still works on bigger things like this. Sorry, it's a little blurry. Let me focus it. Come on. Division of polynomials works exactly like division of numbers did when you were in 4th grade. When do you say bye to somebody? When they're leaving. So the thing that has the word bye in front of it, it's going to go outside of the big division symbol. So on the outside, I'll write x minus 2. And then the thing I'm dividing, well, that goes inside my long division symbol, right? So you don't want to squish everything together, because if you squish it together, the work you do is going to get really messy. It might not even be a bad idea, because I think this goes pretty long. I might actually go over here and write my work. What do you think? Should I do it over here on this side? Or I think just squeeze it. I'll use an index card, just fit it underneath, but you guys, no, because you'll run out of room yourselves, right? We'll try our best. Let's see what happens. Okay. In here, I'm writing x to the third minus 4x squared minus x plus 2. Cairo. So hi, are you guys copying this down? Okay. This is me doing it for real. I did it twice already.
Wait, so I need to copy down the green?
Everything I'm writing now, we're going to copy down. Yep.
I copied them.
You copied it yesterday? Oh, okay, so if you copied yesterday, you're really listening today. The green?
Mine was green.
Oh, okay. I thought you were going to watch then. That's fine. So you copied it once, so we're paying attention now. Now, when you do division, division symbols look like that, right? It's going to be our fill-in-the-blank fraction. Inside is x cubed, right? The inside is our royalty. They're upper class, so they go in the top. And then on bottom, what do I put on the bottom? What term? X. You do the line meters divided. So I start with my first line meter divided by outside line meter. What's x to the third divided by x equal? Good. X squared. Now, I went over here. Now, I'm going to go around. I'm going this way. So I'm going to grab another color just to point the light. I'll take pink. So I started here, essentially. Now, I divided and I got x squared. So I'm going to go right there and put my answer x squared down, right? After I get x squared, what do I do with x squared? What do I do with x squared? Yep, we're going to multiply it by the x minus 2. But where do I write it? Underneath. Good. So what's x squared times x minus 2? Good. X cubed minus 2x squared. What's the thing I keep saying over and over again? Parentheses. Minus sign. I really only say parentheses once, but you could say it twice. Minus sign. Underline. Cancel. Good. Underline. Cancel. All right. Now, just a warning. A reason it's important, Jeremiah M., a reason it's important is because when we do synthetic, it's addition. So the minus sign here is going to remind you to subtract, but the other one I'm going to say something to remind you to add. So I don't want you to mix them up. Next. Parentheses, minus sign, underline, cancel. Why are the parentheses here? To remind us what? To do what? Distribute. Good. So this is what I have left to do. What's negative 4x squared? What's minus negative mean? Negative 4x squared plus 2x squared. What do we get? Negative 2x squared. Bring down the minus x next. Now what do I do? Say it again. We only do one more term because you're dividing by 2 terms. So you're really going to focus on 2 things at a time. Okay? So now I'm going to draw another little division symbol over here. Now who do I divide? Who's the new line leader inside? Underneath the roof, in the castle. Who's the new line leader? Yeah, negative 2x squared. Good. Negative 2x squared divided by? Still divided by the lower class, who's on the outside. So here's the castle. The upper class lives here, the royalty. So upper class is at the upper part of the fraction. Lower class leader is on the lower part of the fraction. Okay? What's that equal? Negative 2x squared divided by x? Good. And where do I write that answer? Good. So I'm doing my little arrows again. So this then went there, but then that answer went here, okay? So it's going to keep looping around and around until we're done. So negative 2x goes here. Then what do I do with my negative 2x? I take that answer, so it's just like fourth grade division, and I multiply it by that. I'm just showing my work on the side. A lot of people will like to do it in their head, but I think it's safer this way. So negative 2x times x minus 2. And what do we get? Negative 2x squared minus 4x, parentheses, minus sign, underline, cancel. Now we subtract. What's negative x? Minus negative means plus. So it's negative x plus 4x. Negative x plus 4x. Yeah, I'm just going to scoot it over here. 3x. No, it's plus because it's minus negative. That's the only real sneaky step over there. So it's minus negative, which is plus. So that's how I got 3x. So this answer right here, I wrote it over here. And then I would bring down the plus 2. Who's the new leader? Work for my division is 3x. What's 3x divided by x? That's 3. Once you get a constant with no x, you're like basically done, home stretch. Then I take that, write it up there, plus 3. Then I take that, so I went from this to this, got my answer to that. What do I do with the 3? I take the 3 and I go and multiply over there. What's 3 times 3x? Oh, is there a mistake here actually? Yeah. Because what was negative 2x times negative 2?
Oh,
Yeah. So Kyra, remember, it's behind me over here too, the problem, remember? Thank you. I felt like, the numbers didn't seem familiar anymore. So then instead of that being a 3x, it's a negative 5x, right? We still bring the plus 2. Then what's negative 5x divided by x? Negative 5x divided by x is negative 5. That's what we wrote up here now, so I have to fix all this. It's okay, though. Negative 5. Oops. Minus 5. And then what do I do with the negative 5? Over here. And what do I get? Negative 5 times that is good. And then last time, parentheses, minus sign, underline, cancel. Now it's 2 minus 10, which is negative 8. So this part up here is my answer so far. And all I'm going to do is I'm going to do minus for the 8. 8 over x minus 2. And we're done. Now, that's a hard one. It feels hard because it's, new or not that familiar. But then we're going to do the one under it, and it should help. The one under it is an even bigger power, so it'll actually have more steps. And honestly, the more steps helps you kind of see what's going on a little bit better. Sam, question? Go ahead. In a minute. Just let him go first. All right. Are we ready for the next one? Just maybe it'll start sinking in. I'll have more practice of this set up for us on the side, so we can get into it later. But really, this page, we have a few examples. The very bottom one is synthetic, but we'll first do it with long anyway to compare. So I'm going to go over here. Now, if this is not enough room, it might not be a bad idea for you to take a piece of paper and do it with the piece of paper, okay? So if you want to do it there so that you don't have to squeeze it, I would say that is a good idea. I'm going to use an index card. I even have extra index cards, so if you want to take one and then tape it down so it's like a little liftable flap, you're more than welcome, because I'll have extra over here. So if anyone wants one, I'll take some over here, and over here on Jay's desk. Okay, so pass around. Armand, you good? Okay. So, and then I have Scotch tape here, so then you can just look at this, and I'm going to just cover it up a little bit, put a piece of tape down. Okay, so then I can do that when I need the other problem, okay? Okay, here's the other one. I'm going to divide, I'm just going to highlight the problem a little bit. This is what I'm dividing, x to the 4th minus x to the 3rd minus 9x squared plus 6. I'm going to divide that by x plus 1. So, if that's what I'm dividing, what do I put in the outside versus the inside? Good. So leave some room above it, right? Outside, I'm going to put the x plus 1. Nice and neat. Best handwriting ever we could do. Then set up my division. And then that is going to go inside, right? So nice and neat. X to the 4 minus. X to the 3rd minus. 9x to the 2nd minus 10x plus 6. Just extend that a smidge. There we go. Now, I'm going to show it to you a little bit differently. You'll be able to kind of check this on the video if you want. I'm just going to add color as I do each step. First I'm going to do x to the 4 divided by, what color can I use? I'll do this. X to the 4th divided by x. So I'm going to circle this x with the light blue. Okay? So on the side, I'm going to have x to the 4 divided by x to the first, just plain x, right? And what do I get for my answer? Good, I get x to the 3rd. Where do I write my x to the 3rd? Yeah, over that one, x to the 3rd. Then, so I'm going around and round and round I go. Keep going like this. So if you're ever stuck, do you see I keep making like counterclockwise circles? Wherever you are, just keep the counterclockwise circle going. It's going to help you remember where to go. What do I do with this? I heard it, good? Multiply. We're going to multiply by this, but remember I put parentheses so you remember to multiply by both things, okay? So what's x to the 3rd times x? Good, it should match. If it doesn't, we're in trouble. Then plus x cubed. Then I do my little line over here, right? Parentheses, minus sign, underline, cancel. Very carefully here. What's negative x to the 3rd minus x to the 3rd? Good, negative 2x to the 3rd. And what do we do next? Bring down, we want two terms, so minus 9x squared. So we do 2 chunks at a time. Now, who is the new line leader now? Good, negative 2x cubed. So that negative 2x cubed is right there. I'm going to divide negative 2x cubed by the x on the outside again. I know it's a little dark, that one. I'll go over it in a black pen in a second. So that's negative, actually I have one here. Negative 2, does that little show up a little better? X to the 3rd, and then here, negative 2x to the 3rd divided by, what am I dividing by? Good, just the x on the outside, the leader. And your answer is? Good, negative 2x squared. And where do I write my answer to negative 2x squared? Above that, good, negative 2x squared. So going around. Now what do I do with my negative 2x squared? By that, right? So what's negative 2x squared times the entire x plus 1? Negative 2x cubed minus, well, it's negative 2x squared times positive 1, so minus 2x squared. And then we always say, parentheses, minus sign, underline, cancel, right? Next, what is negative 9x squared minus negative, which means plus. So it's negative 9 plus 2. Good, negative 7x squared. What do I do next? Before I can continue. Good, we bring down the negative 10x. Now, just because I have Scotch tape on my paper, I'm about to try to run a highlighter over it, I'm just going to cover what I just wrote in the pen with a piece of tape again so it doesn't smudge. You know? So there I am, and I'm going to highlight that again. So now I have negative 7x squared, negative 7x squared. I'm about to divide that one. So I'll write it over here, negative 7x squared divided by x. I didn't really get myself a lot of room, did I? Divided by x, and what do I get? Good, I'm just going to squeeze it, but negative 7x. I don't really like how I did that, huh? And of course, I didn't use erasable pen for that part, but what are you going to do? I'll put it on the next line. So I'm going to go here, I'm just going to scribble that out. And I'm going to write equals, and I'm going to write negative 7x over here, sorry. So the negative 7x squared that I divided is right there, that's just the work. And we said we got negative 7x, and where do I write that negative 7x? On the top, loop around. So negative 7x. And what do I do with this negative 7x? Multiply it by? Good. And what is negative 7x times x plus 1? Good. Guys, can more of you try to participate a little? You know, it's going to help you remember. Then after you write this thing down, what do you do next? Parentheses, minus sign, underline, good, and cancel. Thank you. Minus negative really means plus. What's negative 10? Because that's already canceled, right? What's negative 10 plus 7? Negative 3x. Now we bring down plus 6. Am I still on the screen? Yes. Okay. Now line leaders again. What's negative 3x divided by x? So I'm just going to... Well, it was negative 10 plus 7, so negative 3. That was good. Yeah. Negative 3, and then divided. Okay, so next, what color do I have here? Orange. What is negative 3x divided by x? Negative 3. So where do I write that answer? What's negative 3x? Where does negative 3 get written? Every time I get my answers, I keep looping around. So where do I go? Josh, where does it go? Of the next to the 7x, so above the 6, so it should be in the column, right? Yeah. Negative 3. What do I do with this negative 3? By x plus 1. What's negative 3 times x plus 1? Negative 3x. And then negative 3 times 1? Armand, sit up. Negative 3 times 1? Negative 3. Parentheses, minus sign, underline, cancel. Minus negative is plus, again. So, what's negative, or what's 6 plus 3? 9, but we're at the end of the line. So what's 9? 9 is it's the remainder. So I'm going to highlight this with another color here. I'll write over it in black so you can see it a little bit better. That remainder, where do I write my remainder of 9? Yeah, we're going to write it up top. So we're going to write it as plus 9 over x plus 1, the thing we divided by. And you're done. So I'm going to do a little extra step here. When I divided this pink, I got this answer, which I'm going to circle in pink, and I'll write it over here. Do you see how I'm like kind of color coordinating it? Purple, I divided the 2x cubed, right, negative 2x cubed, and I got negative 2x squared as my answer. So I'm going to write that over here. And then from there, I did the yellow division. I got this answer of negative 7x. I wrote that answer up there. And orange work was right here. I got this answer of negative 3, and I wrote that right there. My very last thing was my blue remainder, and because it was positive 9, I got that right there. So this is actually color coding and showing all the work that kept looping around in circles. Okay? Kind of get it? Question? Go ahead. Go. All right. So over here, here's all the work worked out. Is anyone still copying? Okay? So when you do this again from, like, say, the video, I would say put your paper away, shut your packet, and do it over with the video on a plain piece of paper. It's going to be the same kind of setup. So I'm going to lift this card. It's all in the video, okay? I'm going to lift this card, and what I'm going to do now is... Okay, so the next problem we're going to do is the remainder theorem. We're going to use the remainder theorem to determine if x plus 1 is a factor of this polynomial right here. That means if we do division, the remainder, if that's 0, it means it is a factor, but we're not going to do the division, we're just going to plug in the number instead. So we can look at this question in 2 different ways, okay? It could go in 2 different orders. So for now, I'm going to use it in the direction of the following. If I'm dividing by x plus 1, you take the thing you're dividing by and you set it equal to 0, and that's going to give us x equals negative 1. Okay? Then we're going to take negative 1, and we're going to fill it into our equation. So the p of negative 1, that just means we're filling in negative 1 everywhere we have an x. You do want to be careful with parentheses, especially if you have a calculator. So we have negative 1 to the 4th power, and then we have plus 9 times negative 1 to the 3rd power. I'm going to erase this line over here, because I actually need to cut off the space there. Minus 5 times negative 1 to the 2nd power, minus 5 times negative 1 to the 1st power, minus 10. Now, if I evaluate it, I took the thing I was dividing by. I want to know if that's a factor, so I'm dividing into it. I set it equal to 0, solve for x. I filled that in for x. Next step, p of negative 1. I'm just going to simplify this. negative 1 to the 4th power is 1. And again, you could type this all on a calculator in one shot, but I'm just going to break it all down to practice. So 9 times negative 1 cubed is negative 1, minus 5 times negative 1 squared is positive 1. Negative 5 times negative 1 is positive 5, minus 10. From there, the p of negative 1 equals 9 times negative 1 is negative 9, so I have 1 minus 9. 5 and 1 is just minus 5. That's this. And then plus 5 and minus 10. I guess I'll just write it all out for now. Okay, next. 1 minus 9. That's going to be negative 8. Minus 5 and plus 5 actually cancel each other out. Minus 10. Negative 8. P of negative 1. Negative 8 minus 10 is negative 18. So that would mean no, x plus 1 is not a factor. If it were a factor, then when I plug it in, I would have gotten 0 as my answer. So I'll even write negative 18 doesn't equal 0. That's why. So this is one style of using the remainder theorem. So always remember, if it's using the remainder theorem, it's really using sort of a shortcut or trick or alternate option. So that's the question the way it is. But what if I change the question? What if the question just asked me, use synthetic division. This is a bonus question. Synthetic division to find the p of negative 1. So now I'm turning it around. Now I want you to use synthetic division to find the p of negative 1 instead. So this is normally what we're accustomed to doing. It's an awful lot of writing. If we use synthetic division, you're just going to take the number that we're plugging in or evaluating. We're going to go over here and put that as our box number. The other numbers, my coefficients, will come from p of x. So those numbers are 1, 9, negative 5, negative 5, negative 10. Oops, sorry. Fix a little bit there. Okay, and I will color it off and block it off a little bit. Let's look at that as well. So, okay. Okay, so again, this is just a little alternate question on like how things could be spoofed and turned around. So I just kind of changed up the question a little bit. So 36, version B. Okay, and the p of x applies to this problem. And then we started our work right there. Okay, we put our coefficients, we leave some room, and we draw a line. Don't lose this little 1 over here. We bring down the first number, and of course I didn't really give myself that much room, so I'm going to go. Okay, bring down the first number, I get a 1. Bottom times box, that's negative 1. Add them straight down, that's 8. Bottom times box, that's negative 8. Add them straight down, that's negative 13. Bottom times box, that's positive 13. Add them straight down, that's 8. Bottom times box, that's negative 8. Add them straight down, that's negative 18. Go over here, close off the box. This last box is the remainder. Can't fit it here, I'll put it sideways. I'll just put a big capital R. That is your remainder. So we use synthetic division to find it. It's the remainder theorem. So what am I going to do with that? That means that the p of negative 1 must equal negative 18. So your remainder is your answer, just like plugging it in is your remainder. And if your remainder were 0, it would be a factor. Okay? So here I did this problem 2 different ways, 2 perspectives. It's not that I'm solving the same problem. I kind of like inverted it. So here we said use the remainder theorem to determine if this is a factor of that and support your answer. Okay, so how do we explain and support our answer? Basically, we want to say, well, if this is the question right here, we use this function still. We want to say I plugged in negative 1 and I got negative 18 as my answer. If I got 0, that means my remainder would be 0, and that means it is a factor. That would also mean, really, if you've graphed polynomials, then you would know that that means x plus 1 is a factor because negative 1 comma 0 is an x-intercept. But I know most of the some of these classes we didn't go into graphing polynomials yet, others we did, so don't worry about it too much right there, okay? So then this is in conclusion, the answer. And then for the yellow question, use synthetic division to find the p of negative 1. you would put that as your full answer. So you'd find, really, you're just concerned with that number right there. Okay? So hopefully that helps with that. Next, we have just straight up synthetic division for this problem. So this is actually the same as the problem we did for number 35. So we're going to do synthetic division on this question right now. So just to go over some synthetic division. To do synthetic division, you take the thing you're dividing by, which is the x plus 1, and you set it equal to 0. And that's going to give you x equals, subtract 1, negative 1. So you could remember op in the box. The opposite number will always go in the box. If you put positive 1 in the box, it's wrong, 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 wrong. Op in the box. What am I saying? Op, like, opposite, in the box. Okay? Now we put all of our coefficients in a row. 1, negative 1, negative 9, negative 10, and 6. Leave some room. You bring down the first number. And then we say our little line every time. So the line is bottom, meaning bottom number, times box. And by box, I mean the box number, comma, add them straight down. So you just add the numbers. We're not subtracting like with long division. Add them straight down. So I pulled down the first number to start though. Bottom, has to be in the bottom row, times box, negative 1. Add them straight down, negative 2. Bottom times box, 2. Add them straight down, negative 7. Bottom times box, 7. Add them straight down, negative 3. Bottom times box, 3. Add them straight down, 9. From there, you go to your original problem and you look at the power. It was to the 4th power. You decrease your power by 1, so this will be 3rd power my answer. And these are your coefficients, and that's your remainder. So that means I have 1 x to the 3rd, minus 2 x to the 2nd, minus 7 x minus 3. There's my remainder, so we tack it on, plus, because it's positive, 9 over, and we were dividing by x plus 1, x plus 1. So that's your final answer for this problem here. So rewind and watch it again if you forgot or need help or aren't sure if you fully got that correct. Okay, op in the box, very important. And then add them straight down each step of the way. And then your answer is 1 degree less. All right, here we have another set of problems. And these problems are asking us to find the solutions, also known as roots or zeros, of the polynomial equation by factoring. So that's a huge hint to remind you to don't panic. You're super good at factoring. So you're going to just factor. And it even tells you, a big, big hint, begin by using the grouping method first. So the grouping method is where we look at 2 groups at a time and we deal with the greatest common factor. So we're going to go into a lot of detail here to really help everybody out. So the first thing, I sing a little song, and my song is, and it's not really singing, it's more like me talking. So my song lyrics are going to go right here on the side. Underline, underline, greatest common factor. I just want it to be, there we go. So let's just zoom out a little, sorry. And tilt that. So, there we go. Sorry, I'm just fixing the focus now that I moved everything around. Okay. Underline, underline, greatest common factor. I'll add a new lyric every time you finish that part, okay? Again, it's not really a song, forgive me. So there we go. Underline, underline, greatest common factor. So that means you want to decide what's my greatest common factor out of these 2 things and these 2 things. So one batch at a time. My greatest common factor here, if you only write x squared, that's okay, but it's not great. Always use whatever sign the first thing is as well. So I'm going to use negative. Here, again, same problem. If you only write 15, you might run into a little bit of trouble. So we're going to factor with a negative also. Next step, next line, we say bring it out front. By it, what am I talking about? I'm talking about the greatest common factor, okay? Bring it, and I'll highlight that in a second, out front. And we repeat because we do it twice. Bring it out front. And you bring it in front of its own respective spot. You'll see that. parentheses, parentheses. So we repeat it to help us remember, and we try to say it the same way every time. Okay, so I'm going to go over here, and that's it that we're talking about. And then I'm just going to highlight greatest common factor in yellow as well. Okay, from here, bring it out front, bring it out front. So that means negative x squared, negative 15, parentheses, parentheses. So for the parentheses part, okay, it's just setting up that you have parentheses made. Okay? Next. Oop, I cut it off a little. Forgive me. Okay. Next. Next part, the words are pretzel, pretzel. Then you ask, what goes inside? So pretzel, like the food, it's going to look like a pretzel that we're going to draw. Something over here. And what we're going to draw are essentially little pretzels. So my pretzels are one part here and here, like these ovals going around, because you have to remember when you divide the bottom, it has to go into both things on top. So the pretzels are based on these little ovals. What goes inside, that's what you're going to figure out. It's going to go inside these orange parentheses. So by inside, obviously I'm referring to inside the parentheses. So if I try to do some little division here, what is negative x cubed divided by negative x squared? The negatives are gone, and I'm just left with an x. What's positive x squared divided by negative x squared? That's going to be negative 1. Now this one, negative 15x over negative 15 is x. 15 divided by negative 15 is negative 1. So looking pretty great. So this is where we sometimes need a little bit of a reminder that if I gave you something like, I'm just going to ignore the negatives for a moment, but if I said x squared y minus 15, or even make it plus for now, 15y, since I'm ignoring the negatives. So if I said to you, like, oh, we're factoring this thing over here, what is my greatest common factor that I can factor out front, right? Well, your greatest common factor would have been y, okay? So I'm just going to label this side example. Okay, so y is your greatest common factor, and you pull that out front. What's left inside? You basically ignore it, and you're just left with the x squared plus 15. So I know it looks different because our matching thing is not just a y, right? Our matching thing is an x minus 1. So the next part of the song that we say over and over and over, because we practice all the time, is if it matches, you're winning at life. So it matches. We're winning at life. Bring it out front. So I'm going to bring it. And again, what do I mean by it? Now I mean it. So the new it that I'm going to bring out front is the x minus 1. So x minus 1, we brought it out front. And then the last part is what's left inside. So if we bring it out, if you see in the middle side example, I crossed it out when I brought it out. So really, I brought this out front. What's left inside? It's really negative x squared minus 15. Now, if it's multiple choice, your answer just might be slightly different. So they might just leave the x minus 1 the way it is. But then this has a GCF of negative 1. So maybe the negative comes all the way out. And then this now becomes x squared plus 15. You also could have divided by 15 right from the beginning. And actually, I had a little mistake going on because I didn't put equal 0 every step of the way. So, oopsie. So that should be equal 0 squeezed in over there. Then, actually, I'm just going to squeeze it here instead. So it's not after the little star. So equals 0, and then equals 0, equals 0. Okay, so now, really, we're going to set each parentheses equal to 0. So, and also you could just divide right now or in the beginning by negative 1, and now the negative's gone. So then you'll have x minus 1 and x squared plus 15 is 0. X minus 1 equals 0, and x squared plus 15 equals 0. X equals positive 1 is one answer,
and x squared equals rather, negative 15, then we're going to go ahead and take the square root ourselves of both sides. When you take the square root, you have to put plus, minus in front. And then the negative, I hope you all remember, it turns into an I, and 15 is the only thing left inside. It actually does not simplify, so in this case, we just leave it the way it is. So my final answers are going to be highlighted in pink right now. So my final answers are those, this one real answer of 1, and these two imaginary answers of positive and negative I radical 3. So that was number 38. Now I wrote out all the words, and that was how we factored the problem. So now that I wrote it out already, I'm just going to solve the one underneath it without really going into too much detail. This time, however, I'm going to divide both sides by -1 first. By doing that, I don't have to deal with that negative later. So it's just going to be x to the third. And now remember, everything changes signs. So x to the third minus x to the second plus 7x minus 7 equals 0 divided by anything is 0, unless you divide by 0, which you're not even supposed to do. So it would be undefined. Underline, underline, greatest common factor. Here I get an x squared. Here I get a positive 7. Bring it out front. Bring it out front. Parentheses, parentheses. Pretzel, so you might just draw it lightly. Pretzel, what goes inside? Well, that's going to be x minus 1. Here as well, x minus 1 equals 0. If it matches your winning at life, bring it up front. There's x minus 1. What goes inside? Well, that's gone, so you have x squared plus 7. Still equal to 0, right? And then we solve by setting each piece equal to 0. So I'm just kind of going over here. That means I'll have x minus 1 is 0. Add 1 to both sides. You get x equals 1. Here, similar to the last one, x squared plus 7 is 0. So x squared equals negative 7. Take the square root, plus minus goes, I is for the negative, and only a 7 is left inside. Sorry, I squeezed it there a little bit. And now this one, I will color coordinate as green. So number 39 is green, and my answer is this x equals 1, and x equals both positive and negative I root 7. I skipped a little bit of a step simplifying, but hopefully you guys can figure that out. Okay, next we have just some solving with square roots. And everybody knows, I think we're all pretty good at knowing that a square root basically goes away when you have a square. So we want to square everything. We can't do that yet. You definitely need to start by getting the square root part alone, okay? We've done lots of things like this. So we want to get this alone first, okay? Same here. Get that alone first. So I'm going to put a little note with the yellow highlighter on the side. So it's going to say, get the radical, or square root, alone first. How do we get this radical alone? We're going to start off by adding 6 to both sides. Sorry, the focus. Okay, so that means we have the square root of 3x plus 22 equals x plus 6. Now, what is the one thing that helps us get rid of a square root? Well, to get rid of a square root, I had orange, so I'm going to switch to blue, which is actually across from orange on the color wheel. So they kind of sort of symbolic. Because we're going to get rid of our square root by squaring each side. This is called the inverse operation. The square and the square root, adios. We're left with this 3x plus 22. On the right, we've gone over this a bunch of times. When you have something squared, it means it's times itself. You have to write it twice. Super, super duper important. Now I'll FOIL that, or distribute really, because FOIL is just a mnemonic device. 3x plus 22 equals x squared plus, that's first times first, outer 6x, inner 6x, and last times last is 36. Just going to continue my work over here. 3x plus 22 equals, I can combine like terms, I get x squared plus 12x plus 36. Another thing we stressed is we want to get my equations equal to 0 when we're factoring and solving. So I'm going to subtract 3x, and I'm also going to subtract 22. That will leave me with a 0 on that side. 0 equals x squared plus 9x, and then 36 minus 22 is 14. Now we have a nice quadratic trinomial that we're going to go ahead and solve by factoring. If you want to use AC method says 1 times 14 is 14. That's my A. C. What multiplies to give you 14? 1 and 14, and 2 and 7. B for but what? But it's got to add or subtract to give you 9. Well, that'll be a positive 2 and a positive 7. So the next step, we'll get 0 equals. Now, we keep calling this a quadratic, but where's the quad? Quad means 4. The way you get it to become a quad, we build a quad by splitting that middle term up. X squared stays the way it is. Then we use plus 2x plus 7x plus 14. From here, we do the grouping method we just did up top. So I'm just going to slide a little bit. So we're going to do the grouping method. Underline, underline, greatest common factor. Here it's x. Here it's positive 7. Bring it out front. Bring it out front. Parentheses, parentheses. Next up, pretzel, pretzel. What goes inside? Well, what goes inside is going to become x plus 2. This one also, x plus 2. Always double check. If it matches your winning at life, bring it out front. So my 0 equals stays. This is matching. I'm going to bring it out front, x plus 2. I cross it out so I know I'm done with it. What's left inside? X plus 7. But guys, don't stop here. Got to keep going. Now we use something called zero product property. And we're going to set each of these equal to 0. It only works when your equation's equal to 0. Minus 2, minus 2, minus 7, minus 7. X equals negative 2, and x equals negative 7. Now, if you struggle and make a mistake, always check your answers if it's multiple choice to make sure that you exhaust all options. Something like that doesn't really always work on a big test like the SAT, but it is helpful to know that like you don't leave anything at least blank. So at least reason through the available options and see if they make sense. Now the directions here ask us, eliminate any extraneous solution. So extraneous means extra. So that means you're going to take these and plug them in and see if they work. So if I took negative 2, 3 times negative 2 is negative 6. Negative 6 plus 22 is 16. Square root of 16 is 4. 4 minus 6 is negative 4 minus 6 is negative 2. So this answer works. Now the negative 7. 3 times negative 7 is negative 21. Negative 21 plus 22 is 1. Square root of 1 is 1. 1 minus 6 is negative 5. So this answer fails. It actually doesn't work. It does not make it true. That's extraneous. So that's the only answer we actually care about. Sometimes they both work, and sometimes neither answer will work. So you always want to check all cases. If you want to press pause and try the next example now, you could continue watching when you are done solving it yourself, or if you get stuck. I'm going to go ahead and solve it now, though. So plus 4, we want to get the radical alone first. That gives me the square root of x plus 6 equals x plus 4. We're going to go ahead, I'm going into less detail, and square both sides. On this side, I get x plus 6. On this side, I'm going to FOIL in my head, x plus 4, that's x squared plus 4x, which is 8x plus 16. From here, I'm going to subtract x and 6 to get x, everything on one side, so you've got to get it equal to 0. 0 equals x squared plus 7x plus 10. AC method, I'm going to multiply a times c, and I'm going to get 10. Now I want to know what multiplies to give me 10 and adds or subtracts to give me, B for but what? But it needs to give me 7. That would be a positive 2 and positive 5. 0 equals x squared plus 2x plus 5x plus 10. Because remember, we use our middle term. We had F and L for the FOIL, but we only had a middle term, not F, O, I, and L. So we built our quad. Underline, underline, greatest common factor. Bring it out front, parentheses, parentheses, pretzel, pretzel. What goes inside? If it matches, you're winning at life. Bring it out front. What's left inside? X plus 5. Now we're not done because we're solving, so let's finish. X plus 2 is 0. X equals, subtract 2, we get negative 2. And x plus 5 equals 0. Subtract 5, and we get x equals negative 5. And then we check for extraneous solutions, okay? All the time with this kind of problem, we're going to check for extraneous solutions. I just wanted to highlight the answer that worked. If it's open-ended and you have to check for extraneous solutions, you should definitely show your work. If it's multiple choice, then obviously we really don't need to show work, but you should definitely show it if it asks you, or at least cross out an answer that doesn't work. So, negative 2 plus 6 is 4, square root of 4 is 2, and 2 minus 4 is negative 2, so that one works. So x equals negative 2 works. This one, we have negative 5. Negative 5 plus 6 is 1, square root of 1 is 1, 1 minus 4 is negative 3, so x equals negative 5. Didn't work this time, so that is the answer, similar to the last example a bit. Okay? So we'll just highlight that. I think there's just a couple more. All right, on the next page, we just have a few more examples where we need to solve. All right, here we're continuing, similar style. It says, what is the solution of the equation? So same rule is going to apply. We're going to get this alone first. But if you notice, there's no x outside of the square root. So if there's no x outside of the square root sign, you will not have any extraneous solutions. So you don't need to even worry about checking. If you want to just make a habit to check every time, that's definitely great, but you don't need to in this case. Plus 6, plus 6. We're going to get the square root alone first. That's gone. Next, you have the square root of x plus 9 equals 9. Do not make up your own rules. I think you could kind of start to realize when you are making up your own stuff, okay? If it's not like anything you've ever done before, and you're like, oh, I totally could take the square root of this random sum or difference, I don't think so. And I think you'll know pretty certain that like we've never done that. So don't make up your own stuff. Now, we're going to square both sides. We don't need to do any distribution or FOIL because you are going to square the square root. Those just eliminate one another. They undo. And then you're just left with the radicand, which is the name of the thing inside your radical, x plus 9. And then 9 squared equals 81. From here, isolate x. We're going to do minus 9 on both sides. And just because I could squeeze it, but I'll get x equals 81 minus 9. If you have a calculator, use it if you're not sure if you're correct. And your answer is 72. So I'm just going to draw a little arrow. I'm just going to rewrite it here because it was squashed. Answer, x equals 72. Okay, that's all we got there. So that was that one. And next we'll have, let's do a different color for this. So there's my original problem in orange, and my answer also matching in orange. Okay, in green, we will do the next question. And this one is 7 plus the square root of, happens to be x plus 9 again, equals 10. And for this one, we're going to start by subtracting 7. Minus 7 minus 7, that's gone. Square root of x plus 9 equals 3. We get rid of our square root by squaring both sides. So the square and the square root are gone. You're only left with x plus 9 equals 9 minus 9 on both sides. Don't be afraid of getting 0 for an answer. We just get x equals 0. Nothing wrong with that. So answer for this is x equals 0. Next, you can see the directions. It says, what is the product, which is the answer to a multiplication problem. What is the product in simplest form? State any restrictions on the variable. I'm actually going to also be adding one more question at the bottom. Okay, so all you need to do for these, if you remember seeing problems like this in the past, is where you just factor, and if something matches, we're just going to cross it out from the numerator and the denominator. This right here, q squared, we can't really factor anything, so it just sort of stays that way. And over here, we just have q plus 3, which is already prime. It's already a factor. Times, here, we'll be able to factor this. Some of you might need to go on the side, and we have to go ahead and do that. If you don't need to do this, you could fast forward. So this is just going over factoring. We have a 1 and a 9. AC method. I'm just going to scoot this over a little. We'll do AC, and we get 1 times 9, which is 9. What are the factors? We get 1 and 9, and we have 3 and 3. And we say B for but what? Need the multiple things that multiply to give me 9, but add to give me 6. That'll be plus 3 and plus 3. If you know the shortcut, you know, and I'm just going to show that over here, that really you're using those numbers to get q plus 3 and q plus 3. And the shortcut only works when the coefficient in front of q squared is 1. If not, you don't want to risk it. and you just continue with what you know, plus 3q, plus 3q, plus 9. Underline, underline, we get a q over here, we get a plus 3 over there. Bring it out front, bring it out front. Parentheses, parentheses, pretzel, pretzel. What goes inside? We get a q plus 3. It matches, we're winning at life. Bring it out front. What goes inside? So we get 2 of those. That's what we got right here. So this was just side work. Then on bottom, what kind of factoring is that? Well, that's just greatest common factor. They just have a GCF of q. So I'm going to take a q, and that leaves me with just q minus 4. Now the restrictions on the variable are really good to get on this step. The restrictions are going to be the things that q is not allowed to equal. Q cannot equal. So I'm going to highlight the word restrictions in yellow. And I'm really going to do those right over here. Oops, I'm all cut off, sorry. Okay, you go to the bottom and you look at each bubble. So this q by itself can get its own little bubble right there, its own little factor, its own set of parentheses. And you really aren't allowed to let each factor equal 0. So really, what number would make that happen? You could set it equal to 0 to solve. We could do it in our heads. Don't be overconfident. It is going to be more, when the coefficient's 1, you're going to get that opposite number there. So negative 3 would be gone, goodbye. This is just can't equal 0. And this is just q can't equal 4. So those right there are the restrictions. That's a really good way to even help you if you have multiple choice, pick out your answers. Now, for the rest of the problem, we're going to reduce. Anything on bottom, on top that matches as an entire factor, we can cross out. So q plus 3, one of them crosses out. Here, q squared really means q times q, so I'm going to get rid of that squared because one of them cancels out with one of these. So what is going to be left? So then, those q's canceled out, so that means only one q is left on top, q to the first power. Okay, so then that leaves us with q times q plus 3. Those are q's, sorry, they're ugly. Let me go do this. There we go. And there we go. Is that better? I don't know. Over q minus 4. So what is the product in simplest form? We did that. So let me just color coordinate again, like I do. So here's simplest form, all done. Okay, sorry, my green highlighter sort of drying out. And then my restrictions are right there. If it's multiple choice, it is possible, though, that they write the answer with the top expanded. I don't know if it will be. I'm not sure. I can't speak to that. Actually, I mean, it could, because I could go look at it, but I'm not going to do that. So right there, still good, too. Good, too. Okay, so that is also fine. Right there. And now the last one for the moment is going to be, and actually, what I can do is I'm actually going to change this problem. Let's change it to a division problem for right now. Or actually, no, because some of you did it that way already. So, and you're going to check with another key. So I guess I'll leave it the way it is. So a squared on top stays. A plus 1 is already prime. That stays. If you factor this by grouping, you'll get a plus 1 and a plus 2. On bottom, GCF comes out. You have a times a plus 1. Any factors from top or bottom that match, you're going to cross out. A squared, I'm just going to look at it differently this time. I'm going to look at it as a times a to help out from before. And now, crossing out and reducing our fraction, we'll get a plus 1, reduced with a plus 1. We could go diagonally top and bottom, as long as it's all multiplication. A with the a. So again, we are left with simplest form, which is a times a plus 2 over a plus 1. And then the restrictions all come from my denominator can't equal 0, so a cannot equal negative 1. That's for that. A cannot equal 0. Even though we crossed it out, it still can't equal 0. And here's negative 1 again, so really I guess that's done. You don't need to list it twice. That would just be kind of silly. So I do owe you one division example. Oh, I didn't color coordinate that part, so let's do. That's simplest, and those are restrictions. So the bonus example, I know some people have one written in their packet for other classes. I don't have that one handy at the moment, so I'm just going to make this up, flip it. So what if the original problem instead was a squared over a plus 1? So it's just like that one. And if it said divided by a to the second plus 3a plus 2 over a squared plus 1a. If it's division, when you divide by a fraction, that's the same as multiplying by the reciprocal. This part stays a plus 1, some of you guys will call it same change flip, times, change the sign, flip. So we'll get a squared plus 1a, and then a squared plus 3a plus 2. Do the same drill as before. Oh boy. That gives us a squared over a plus 1 times factor a and a plus 1, a plus 2 and a plus 1. Cross out any factors that match from top and bottom. There's a little catch with this though. A squared, one of the a's still, oh, just kidding. They don't cross out this time because now all of the a's are on top, so none of them cross out. It's a little different. Okay, so that means we get a to the third on top over a plus 1 and a plus 2. So there, that's pretty good for simplest form. And then my restrictions, if it was ever in a denominator, you have to use it. So here, we would use this, a plus 1. So a cannot equal -1, comma. Now, both things from here, which are right there, so also can't equal 0, can't equal -1 again, okay? Now, what about these that are on bottom now? So -2, and that's -1 again. So I have 3 restrictions this time, whereas in the other example, I only had 2. So when you have a division and you have to flip and multiply, we know bottoms can't be 0. We've been doing that since the beginning of the year, talking about not allowed to divide by 0. Now, that's always been important. And then we just say what numbers would cause that to happen. All right? Hope that helped.